Any question? So if no question, thank you for lessons listening me. Thank you.
Thank you, ma'am, for your mindful lecture session. To express our heartfelt appreciation, we would now like to facilitate our esteemed speaker. May I kindly invite Dr. Kapoor, sir, to present a token of gratitude to Agrawal, ma'am. Thank you, ma'am, and thank you, sir. Now, for the fourth plenary lecture of the day, we are delighted to have Dr. Tapas Chatterjee, sir, to present Sir's inspiring biodata. I would like to call Mishika.
Thank you, Apurva. It is my privilege to introduce our distinguished speaker, Mr. Tapas Chatterjee, sir, the Managing Director of SSP Private Limited, with a remarkable career spanning over 5 decades. Sir has been at the forefront of process technology innovation, particularly in evaporation, drying, and extraction technologies. His work has significantly contributed to sustainability-driven process solutions and industrial advancements both in India and internationally. A postgraduate in chemistry, Sir has 10 patents to his name, with 5 more awaiting approval. His relentless pursuit of affordable, adaptable, and commercially viable solutions has revolutionized industrial processes, making technology more accessible and efficient. Under his leadership, SSP Private Limited has built an innovation center recognized by the DSIR Government of India since 1986. This center is a one-of-a-kind facility where industrial processes are tested and proven using real-world raw materials before full-scale implementation. With a customer base spanning over 50 countries and 2,000 plus industries, SSP is a trusted name in industrial process solutions. Today, Sir will share his insights on sustainable process innovations and how they shape the future of industry. Please join me in welcoming Mr. Tapas Chatterjee, sir. Thank you, sir.
Namaskar. Can you hear me at the back? So at the outset, let me make a confession. I am not Mr. Chatterjee. He is our managing director, and he has been called upon for an outstation visit, so he could not come. And he asked me to face research scientists, academicians, which is not a very easy thing to do for us who are just commercial people. At the outset, let me make another confession, that is that this organization, SSP Private Limited, is not a research foundation. Neither it is associated with academics. We are out and out a commercial institution. So, I think, so we have about our headquarters are in Faridabad, which is just adjacent to the Delhi-Haryana border as soon as you cross the toll center. And then we also have our innovation center, which is just about 1.5 kilometers away from our headquarters. We have 3 manufacturing facilities, which are about 30,000 square meters of floor area. And we have somewhere around 2,000 projects in more than 50 countries. And this has been going on since 1977 when this company was started. And I'll come to the Innovation Center later on, but next slide. This is our journey. I won't stop at every point. This only gives you the input as to, I mean, if this presentation is available to you later on, then you can, if you are interested, you can have a check. but we have been there in the forefront of providing innovative technological solutions which are practically implemented in the industry for nearly now more than about 4.5 decades. Next slide. So these are our corporate office over there, our innovation center, our 3 manufacturing facilities. Next slide. And this is interesting. In 2015, we bought over a company in Canada, and they are a 100% subsidiary of our Indian organization. The main objective was, of course, to penetrate the Canadian market, of course, the American market, the Mexican market, and the whole of Americas. And another objective was also, because sometimes reality is that Indian technological solutions are looked down upon by the Europeans and the Western media. So a Canadian name and a Canadian brand carries a bit more credibility in certain sections of the society. Okay, can you go on to the next slide? Well, we are equipped with all the necessary quality certificates that an organization like us should be possessing. It's the latest state-of-the-art systems. Next slide. And we have all the necessary softwares and design and drawing mechanisms that are there which are required to have projects of these kind of scale of operations. Now, our core competence is fundamentally in evaporation. These are the various types of evaporators we have been working on. Those are the pictures on your right-hand side. Then next slide. Industrial evaporators, industrial dryers. Next slide. Extractors, agglomerators, aroma recovery, crystallizers. We work with all these. So maybe you are wondering as to why I am here. So we will come to that a little bit later. This is the footprint that we enjoy all over the world. And if you see the Russia, we've got a little less, but believe me, after the Ukraine war, we have a lot of inquiries from Russia. As I am talking to you now, we have a delegation from Russia, a delegation from Iran, who are doing some innovation testing in our innovation laboratories. Next slide. What you now see is our center of innovation. This is something very interesting. We have nearly 2 acres of land, and we have created this center of innovation, which is in Faridabad, just across the toll center for about probably 1.5 kilometers from there. So if you are in Delhi, you are most welcome. We invite you all to come and see real innovation in action and translation into commercialization. Okay, so we have 2 distinct divisions inside this innovation center. The first one, of course, is the R&D laboratory. I'll come to this just a little bit while. And the second one is the demonstration plant cluster. The demonstration plant cluster comprises of industrial size equipment, not small pilot plants, but industrial size equipment. And what we do is, we do our testing, our conceptualization, everything in the research and development laboratory. We discover the various routes we would like to take to find a solution to the problems that our customers get to us. And thereafter, if we find that we are really getting some success, we take it over to the demonstration plant cluster. That is the time when we tell our customer, please send us the raw material in bulk, 500 kilos, 700 kilos, and so on and so forth. And we finally make the product in the demonstration plant cluster and show it to our customers. If he's satisfied, he may tell us that please make a complete plant of this capacity for us. So there comes the next challenge, that is scaling up. Okay, now, next slide. So if you have a look at this, these are the equipments we've got in our demonstration plant cluster. Just see the top one, triple effect falling film evaporator, 500 kilograms per hour. I doubt if there is any institution which has only for testing and demonstration purposes equipment of this kind of capacities. Next slide. This is again what we have in our demonstration plant cluster. What you see on the right-hand side are the real pictures which would look to you as if it is a proper industry in function. What we do is that we have got all these various equipments inside this place, and when we have a particular process, then we rig them up and configure them according to the requirements of the process. And then we call our customer to witness the production of the product that he is making. And it's quite interesting, by the way. Let's go to the next slide. This is the laboratory facility that we have created over the years. Next slide. These are a few pictures of that, but now we'll come to this. These are the list of available facilities, and if you do a little bit critical analysis of this, then you will see that we are well equipped to do our own calibrations and our own research results. And it is as good as any outside laboratory that we rarely ever go out and get things tested. Next slide. Next slide. I just brought in a few specimens to make these youngsters a little more interested in this presentation. Actually, we are a commercial organization. We only take innovation assignments based on our customers' request. For example, go to point number 8. It is an interesting example. Somebody came from Bihar to our managing director and said, "Sir, मैं कत्था बनाता हूँ और 48 दिन लगते हैं इसको सूखने में और गंदगी फैलती है. Give us a solution for this." We worked on this for 2 months. We had that bark of the tree coming to us all the way from Bihar. We converted it into powder. We gave him a solution. Today, that manufacturer is making sterilized katta in 30 hours in place of 48 days. Of course, we earned a lot of money because we had nearly about 4 or 5 other katta manufacturers who came to us and said, "Aapne unko solution diya hai, to humko dijiye." Look at point number 1, separation of magnesium chloride, potassium chloride, magnesium sulfate, bromine from Quran Lake in Egypt. We had a request from Egypt Minerals and Chemicals Company. Give us a solution. We have a pond which is full of chemical waste, saline waste, which has come from the industries for 25 last few years, and it's now full, and we cannot dump any more. But it is becoming an environmental hazard. Would you believe it if I tell you that 10,000 liters of that lake saline slurry was transported to our innovation center in Faridabad? We worked on it for nearly 4 months. My friend, my colleague Nitin sitting over there has been instrumental in this project. Then we got the first order for them, and we have executed that order. We are going on to the second project at the moment. And if you are just interested in the values, the second order would be somewhere around $20 million. The lowest one is the one that Dr. Chaurasia just mentioned about ethanol and molasses and distillery waste. So what we have done is we have taken the distillery spent wash, which is a horrible pollutant, and we have converted into potassic fertilizer, potassium sulfate, which is a rare commodity in India, and India is actually importing all this potassic fertilizer from outside. And if any of you is interested, we can even rig up our systems and show it to you. We had about 4,000 liters of spent wash, dirty, smelly spent wash coming to our innovation center. And then we had to bring in the sugar mill owners, and we had to show to them how it is getting converted to real potassium sulfate. And that same potassium sulfate was taken by somebody and was checked, and then they came back and told us it has got more than 95% purity. We were thrilled. So there are these triggers. Somebody came from Dubai and told us that you have made so much of milk powder from cow milk, can you make it from camel milk? We gave him a solution. Again, the camel milk was transported in refrigerated containers. It was then converted to real camel milk powder given. And if you find it strange and funny, then let me also inform you, we have now got an inquiry from Uzbekistan for converting horse milk, or rather mare milk, to powder. That was just to make it a little bit lighter so that you are keeping awake. Now let's go to the next slide. Okay. Now, these are the patents which have been taken by our organization or by our managing director. As you can see, the top 4 are for various processes, and actually they are enhancement, improvement on existing processes. 5 and 6 are equipment based. That there are certain equipments which is being used in the industry, and because of the necessity of our customers, we have tried to play around with them, tried to make them a little more better, and then we took a patent for this. 7, 8, 9, and 10 are specifically waste to wealth technologies. And then in this, what we need to understand is the point number 7. 7 has been converted to a real-time commercial solution in Delhi. Delhi Jal Board gave us an order in 2022 that the sewage treatment plant is throwing out sludge at 22% concentration. And that is being taken by the contractors and being thrown into the fields, agricultural fields, and that has heavy metals, or it is being taken and being put into landfills, which are getting filled up. Can you give us a solution? So then we did this. We convert the sewage sludge into ash, and the beauty of it is we do not use external energy. We use the inherent calorific value of the sludge itself so that it gets converted to ash, and that ash is good enough to have compressive strength to make garden paper tiles or for making road construction. And we are going ahead on this research, it doesn't stop, because now we are trying to extract phosphorus from it. Because in 2029, European Union has made a declaration that no sewage sludge or sewage sludge ash from incineration can be dumped unless and until phosphorus has been extracted from it, because phosphorus is a rare commodity. And here, we are here today because of point number 9. That is the process and systems for recovery of water and solids from desalination plant dry and reject, leading to zero liquid discharge system. We are into all types of activities. The only thing that we need is a trigger. And the trigger must be from our customers. And it's a harsh world out there, sirs. It's a real harsh world out there because we are always in a hurry. Our customers are always wanting yesterday the solution to be provided. Out of the 5 patents we have applied for, you will be surprised to know that one of them was inspired by Haldiram because they wanted us to give them a solution for making poya without any human interference. We gave it to them, they're using it, and after that we applied for the patent, it is still pending. Can I go on to the next slide, please? Okay, desalination, I don't want to speak about it too much because I think you people are much more aware of it. But fundamentally, we are aware of the fact that there is either membrane desalination or thermal desalination. And we know that membrane desalination is gaining more ground primarily because of energy consumption in the thermal desalination systems. Next slide. Okay, so what is interesting is, on an average, 40% of yield is what is more or less achievable generally in the desalination plants. That's what we have seen from all the records and everything. And then the question comes up is, because you see what has happened is, the trigger that came from the industry was, give us a solution so that we don't have to face the Central Pollution Control Board. And our core competence is evaporator, dryer, extractors, agglomerators, and so on and so on. So in most of the cases, what we did was we gave them a zero liquid discharge solutions by evaporation and drying process. But thereafter came another question. The solid that was left behind, can that be utilized for any gainful purposes? And that was the time we started working on this. And it was again triggered by the customer themselves because they said, "Iska kuch ho nahi sakta kya?" That was the kind of language. Obviously, you see, when you leave the laboratories and research organizations and your university campuses, when you face the customer, that's the language that you are going to be encountering on a daily basis. And that was the time which got us thinking, because we have been in the business of saline water handling for more than 3.5 decades. So we know what is saline water. We have given a plant in Kenya where he is producing salt and at the same time he is producing drinking water and selling it. Okay, next slide. This is the very simplified diagram of what we do. The seawater intake goes into the desalination plant, and the desalination plant, then if you add SSP's technology, then we recover vacuum grade vacuum refined salt of 99.7 or 6% purity. We also recover a few salts which are there in the seawater, which varies from location to location, which has been also discussed today. And effectively, next slide, effectively, this is a patented technology. Our Mr. Tapas Chatterjee has earned this patent in 2020, and after that he has assigned to his organization. Next slide. Okay, so we have got desalination plants are recovering over 95% of the intake saline water as fresh water. The technology produces vacuum refined salt, and the technology also is in a position to recover the various salts. And this is not a technical desertion. This is reality that we have worked with. And then this ultimately ends in a zero liquid discharge. This is an extract from the International Desalination Association and Reuse Association handbook of 2024-25, and you can see the quantum of water that is being produced from desalination all over the world. And you can also see the report that has been presented by the Blackridge Research. In short, there is a demand, increasing demand for desalination over the next few years that we foresee. Next slide. The statement of the International Desalination and Reuse Water Association is they need drive new technologies to offset climate change inevitable environmental effects. And the sixth United Nations SDGs or Sustainable Development Goals, number 6, availability of water is a very crucial issue. So she also talks about innovative water solutions for desalination, and that is what inspires us. Next slide. What is being said not by us, but Central Salt and Marine Chemicals Research Institute, that more and more land is becoming increasingly saline in the coastal areas, and more than 500 million liters to 1 billion liters of water would be needed to be desalinated in the next few days, in the next 20 years. Next slide. So, we are asking a very basic question to you today. Why look at desalination in isolation? As far as we are concerned, we would like to look at it holistically, and we would like to look at it as a complete picture. So desalination alone is not something that we would be talking about. This is an extract from the same IDRA handbook 2024-25, and you can read the comments about India and the demand of water that is going to grow over here. We have the 10th largest coastline in the world, 7,500 kilometers. And there is a huge necessity for fresh water because of our increasing population. So when you put two and two together, there's a huge opportunity for desalination to grow. Let's switch sides. Let's look at the salt industry. We are the third largest producer of salt, and this report has come from United States. We are the third largest producer of salt. Before us is China in number 1 position, and number 2 position is US. But look at the left-hand side of this slide. China, in spite of being the largest producer, is still a net salt importer. USA is also a net salt importer. But we in India are not a net salt importer. We are an exporter of salt. And not only that, read the Salt Commissioner's report. There was a great demand of Indian salt in the international market. India, then she's given the figures of 112. So that is 11.2, 12 million liters, 12 million tons of salt last year exported. So what we are trying to get at is, if we are having the largest coastline, if we are exporting salt which has demand, and we also need water, then why think of desalination in isolation? Why not club it with the salt requirement that is there? Next slide. Now, we please see the report that has come from the Central Salt and Marine Chemicals Research Institute. And it is talking about situation rather grave as far as conventional solar drying salt pan technology is involved. It is talking about salt production in additional land will lead to salinity and grace. I'm not saying this. This is being said by Central Salt and Marine Chemicals Research Institute in Bhavnagar. Challenges from reduced sunny days, unseasonal rain, brine dilution, and damage to harvested soil. Another reality is that in the developed countries, you have good vacuum refined salt, whether for roads during the winter season or even for human consumption. But in India and many developing regions, unfortunately, the purity of salt sometimes is going down as low as 80 to 84%. Next slide. Once again, I continue with that. The total salt production may not suffice the entire requirement of the industries in India. That's what is being stated by, again, the CSCMRI. Then we are not able to compete in the global market as far as the quality of salt is concerned. Does not even meet the initial industrial specifications prescribed by the Bureau of Indian Standards. Next slide. That is what brought us to this technology. What you see on your left with the red border is the conventional desalination plant. And what you see on the right is the technology that we offer as an extension to the existing desalination plants. And we are very clear about it. We are not asking for any modification to be made in the existing plants, desalination plants. We are only saying that we will put our plant as an extension to the brine that you are giving and throwing back into the sea. That will be something that is the treasured raw material for us to produce more water and also to produce valuable vacuum refined, highly pure salt. Next slide. This is an overview of what it really looks like when you look at a 100 mld plant, actually in reality. Next slide. So today, if I have to produce 100 million liters per day of desalinated water, I need 250 million liters per day of salt water intake. What we are proposing is that we would, with our technology as an addition to the existing desalination unit, we would be able to bring in 98% yield and also generate good amount of salt. Next one. Just have a look at this figure. This is a basic calculation we did, try to find out the return on investment or the ROI. We are more used to ROIs because everything we do as an innovation in our innovation center, it must have a good ROI, otherwise it does not meet commercial requirements of our customers. So, if you see this, the salt production is about 8,300 metric tons per day for a plant which is producing 100 million liters of fresh water per day. If you multiply this by 300 and if you calculate the figures, what we achieve is just for producing 100 mld of fresh water, we get 10% of the total salt production of the country from one plant. And that is better salt, that does not use land, that is also pure to the extent of 99.6%, we approved it in the market, and at the same time that does not harm human health with the salt pan workers in various places, and that does not depend on seasonal rain and other issues. Let's go to the next slide. This is of a new idea. If we have a new plant, then we can, this is more or less on the same lines and the same effective yield is the same. But this is that if you want a new plant, then we don't need to put in a huge, big intake capacity. This is again the basic calculations which are available. What I am trying to say is read the bottom line. The disposal cost of the concentrated brine will be saved. The same has not been taken into account in the above calculations of ours because that varies from country to country, location to location. And there are guidelines how you can discharge the 7% brine concentration back into the sea so that the marine life is not impaired. So you have to take it down, you have to ensure that it gets diluted. Temperature can be an issue of thermal desalination plants. We have all these hazards. And what we are trying to suggest is that let's not have that discharge mechanism at all. Give us, take our solution, put it over there, and let us have a zero discharge solution available to you. So how does the economic benefits work out? We avoid and we reduce the need for additional desalination plants because the existing desalination plants can be upgraded to produce much more water. We have economic benefits, production of large quantity of high purity vacuum refined sodium chloride, 99.6%. The capex and opex reduction due to elimination of elaborate infrastructure for disposal of concentrated brine, savings, additional cost for pollution prevention, and finally savings, use of eco-sensitive coastal land for solar salt banks or new solar. This is a layout picture of our complete plant configuration. One more. This is the overview that is there. Let me just take this opportunity to tell you something. We are not interested, for us as a commercial organization, publishing of papers, thesis, or even getting a patent is not important. Because we have 600 employees working for us. 600 families depend on the revenue that we generate. We spend 2.5% of our total turnover on innovative research. And why we have got into this field is also interesting. There was the colonial mindset in India nearly about 2 decades back. European technology was the only thing that even Indian manufacturers wanted to work with. Indian manufacturers were not satisfied if I told them that I can also give you an equivalent solution. We had our peers who would copy the designs and drawings for the European concepts and bring them there. But the reality is the ecosystem in India is different. Today, even today, as I am talking to you, the National Dairy Development Board recognizes only international suppliers, European suppliers for the technologies that they get. And see the irony of this. We are the largest milk producer in the world, 240 million tons. The next comes US, somewhere around 170, far, far behind. But 52% of the milk produced in this country is from buffalo milk. 48% is from cow milk. And all European technologies are designed with cow milk in picture because they don't have buffaloes in the first place. So the ecosystem is an important criteria. No wonder when somebody in Egypt asked us, can you give us a solution? We had to get those 10,000 liters of that actual saline waste into our place, tolerate it for 6 months, the bad smell, the bad refuse, and then convert it into something valuable and present it to them. So we are mainly interested in finding solutions that will always bring commercial benefit to our customers. Because if they don't, then we will not be in a position to get some revenue. And if we can't get revenue, we can't keep ourselves surviving. We have even occasions, for example, Tata Chemicals, they give us some assignments once in a while that from battery limit to battery limit, kindly do this research for us and give. We don't know what it is all about. They don't tell us. They just tell us this is the battery limit, this is the battery limit. Do this R&D, tell us whether we can be successful in this. We can work with this and not, and we sometimes do it. But we have a very interesting scenario otherwise. Once in a while, we have people who come to us and tell us that we would like you to produce for us because we have this industrial scale plant. So they would say, could you make this powder of 500 kilos because we want to do test marketing. So I'm just trying to give you the enormity of the scale of operation that we are grappling with. And we are doing with it mainly because that only convinces our customer that yes, we can deliver. And now we come to the last part of what I would like to express to you. Over the years, having done this, we have developed the other expertise. The expertise is how to handle it in a laboratory, take it into a demonstration plant, and then upscale it to a real industrial scenario so that it has commercial viability. And because of that reason, we have had to have everything in-house. The manufacturing in-house, the design systems in-house, the drawing systems in-house, everything we have to bring in all together within our own ambit. And we have an ecosystem working. Our design office is in our headquarters, 1.5 kilometers away is our innovation center. Department of Science and Scientific and Industrial Research mandates that if we have to give you recognition for your research and development, it should be in a different location than your own headquarters or your factory. So it's in a different location. And in Chandpur, which is around 25 kilometers away, we have our factory. So while we are doing this demonstration, research and all these activities, if we have a situation where we need something which has to be fabricated, then immediately it can be designed, it can be drawn, it can be told to the factory and we can. So it's complete research-based innovation ecosystem that we have created for ourselves. Any more slides? Okay, so what are we expecting from INDA? INDA's mandate talks about encourage the appropriate technologies and methodologies to augment desalination. Here we are, madam. We are there in this business. Encourage research and development, encouraging R&D on environmental aspects, near zero liquid discharge, recovery of valuables from brine effluent solutions, that's what we are doing. Cooperating and communicating with national and international governmental and institutional and private agencies. This is essentially the most important requirement. Because what is happening to us, reality is, desalination plant owners, and I'm being very categorically very frank and candid over here. Desalination plant owners turn around and tell us, salt is not our business. We don't want to get into it. Give us a solution for desalination. Salt owners are turning around and telling us, what should we do with desalination? We have got no interest in desalination. So unless someone is there to break both the interests, we will reach nowhere. And that is happening to all the waste to wealth technologies that we have developed. When we took out from spent wash of molasses fertilizer, and we've approached the ministry, we approached the various fertilizer companies, they turned around and told us, we are not interested in pollution. And the sugar mill owners and the distilleries, they are not interested in fertilizers. Who's going to tomorrow bridge these two requirements? And India can be self-sufficient. I welcome you all, ladies and gentlemen. If you want to see our innovation center, if you want to see realistic innovation in action. And by the way, please don't think that we underestimate the good work that institutions are doing, because, and I'm not saying this just because I'm standing here and I need to be polite, because whenever we have a situation that somebody comes to us with an extraordinary requirement, what is our first step? Are there any books available on this? Are there any research papers available on this? Let's see. And that's what we go to. That's the first initial starting point. That's what we scan, that's what we brainstorm on. So if you gentlemen and ladies, if you are not doing this research basic work, then we would also not be able to take the cue from there and start our innovation streams actually. You are most welcome to visit us at any point of time. Do let us know in advance. Sometimes we have an issue where our customers are observing the process and they don't want outsiders to come in because sometimes it's a non-disclosure agreement and they don't want their process to be told. Okay. So otherwise, we will be always very happy to invite you, to show you what we are doing. We've got about innovation center is spread over 2 acres of land, so it is something realistic innovation that we are doing. Yes, sir. I would like to hear any questions that you have. And but too many technical questions. Let me use a disclaimer. This was supposed to be Mr. Tapas Chatterjee's presentation, not mine.
You are Mr. Banerjee.
My name is Banerjee, yes.
Okay. Mr. Banerjee, first of all, on behalf of INDA, I would like to commend your work, what you have done. And I'm sure very soon NDTV, they are also going to recognize your efforts. And of course, President is here, definitely. On through INDA, we are looking for many more associations to you. Because, that brackish water or reject water, what technology you have given 4 years payback period, it is as good as the desalination plant itself.
Yes.
So it is really a very commendable innovation you have done, and I am sure in future it can be brought from 4 to 3 years. You can do it. That would be really good. And as you said, the breathing of using, that salt or other things, fertilizer, definitely those things will come. But as you said, you are taking clue from here, and I'm telling you that these people will be your ambassador. That SSP is there. Please go there and find out.
No, sir.
In future.
Sorry for interrupting you, but just because you said this, I was listening to Dr. Agarwal's presentation. And you know what? It's interesting because we are trying to push this technology and this business, rather business, not technology. Because we have to earn money. We have to be a commercial organization. So we were trying to push this into the market. And we came across a technology which has been given in Indonesia, madam, by a company in Turkey called HBTU. And they call it, they are getting a yield of 82% of water. And they call it OARO, which is osmotically advanced reverse osmosis. That's what they are doing. And they gave it a name called Hybrine. It's a trade name they have done for themselves. Of course, they don't divulge the details, but there are some specifications and details which are there in the IDRA handbook. You must be having it probably. So if you see that, HIREC is the name. That is the only organization and which is working on both salt as well as desalinated water simultaneously.
You know what is the bottleneck in academia? Many institutes, we are doing very good work, but we get confined or satisfied at TRL level 3, 4, and to take it to TRL 9, we need people like you.
Sir, TRL की बात मत कीजिए sir, because we applied for TRL. We applied for TRL for this technology, and we were interviewed by NRDC and NESPER, actually. And I don't know, but they have. See, sir, एक आपसे हम एक दरख्वास्त करते हैं. Reality is very harsh. When we are doing research, आपको हम ऑनेस्टली बोलते हैं, हम उनको रिसर्च भी नहीं बोलते, हम इनोवेशन, these are all decorative words for us. हम तो solution, finding a solution बोलते हैं, simple. Now when we are doing this, sir, तो we have taken 4 routes. We designed 4 routes. इसको ऐसे करेंगे, ऐसे करेंगे, ऐसे करेंगे, and then let's see how it works. Okay. The moment we crack somewhere, हम सब कुछ बोल के उसके आगे निकल जाते हैं. अब वो पहले का जो है सर, उसके वहाँ पे क्या लिखा था, नहीं लिखा था, what paperwork we did, it's very difficult to go back again and take out those scraps of paper because we are always in a hurry. Because please remember, the industry has invested money. He has taken money from the banks. He is not going to wait for me. So I have to rush with my. Now, if I apply for a TRL and if I have to define proof of concept, I have to take out all these scraps of paper, I have to put them properly in this. It's terribly difficult. Realistic innovation, karte waqt, sir, when we are.
What I am talking about, the holistic approach for the innovation ecosystem, and you should come more with the students like this.
Sir, we are open. We are open. आप आ जाइए sir, किसी भी दिन.
Yes. So
we have always invited.
Today you need 600 people, and tomorrow you might need 6,000 people. So
Sir, we have been,
You need to have good people.
we
You
have
will
been,
get it.
we are inviting you, please, we are open to any of
Sure,
these
sure. We are
students
looking
over here.
forward, and
If
I'm
they
sure
want to see innovation
many
in
of these
action,
students
please
will
come, please be in our laboratory, spend some time, and you will be enjoying it when you really see spent wash, dirty spent wash on one side being converted to real white color potassic fertilizer. You will really enjoy it. I can guarantee you that
Thank
much.
you, Mr. Banerjee.
So,
I am Ramesh Rastogi,
yes, sir.
retiree from Baba Atomic Research Center
Yes, sir.
26 years ago. I just wanted to give, I'm not going to tell you anything about your lecture. Your lecture is very excellent. I am only giving you the background how INDA has come.
Okay, sir, that's interesting. Yes.
In 1966, Dr. Vikram Sarabhai took as a chairman of atomic energy from after the death of Dr. Bhabha.
Yes.
He was the chairman of Atomic Energy Commission. And he had a project of agro-industrial complex. Agro-industrial complex to be developed along with the nuclear power plant using the electrical energy for those projects where all the energy can be consumed then and there. So there was one thing about the desalination, 100 million gallon per day
Okay.
water produced from desalination. That was one of the projects. And for phosphatic fertilizer, he said that elemental phosphorus from electrochemical process use huge electrical energy and have a phosphatic fertilizer. The whole concept was agro-industrial complex, and the desalination at that time has been originated in Bhabha Atomic Research Center. At one time, some scientists were working on 1 million gallon per day of desalination plant. Of course, it was a theoretical study, but all the desalination work has been done at Bhabha Atomic Research Center, and from there the INDA has
Emerged.
originated. Indian Desalination Association has originated from Bhabha Atomic Research Center. So this is the background which I wanted to give you, that how this work has initiated by Dr. Vikram Sarabhai under agro-industrial complex based on electrical power generated from nuclear power plant. Thank you.
Thank you. Interesting. Thank you very much, sir.
Me, the current president of INDA. So I have just requested your colleague, Mr. Malhotra, please don't mind sharing the slides. Number two, it will be certainly the concepts and putting the concepts into the reality is what SSP is doing. And what just Mr. Stogi has said is the beginning about somewhere in the 60s. A lot of things have grown, a lot of things needs to be done. I'm sure what he is trying to say, INDA will do. I'm very rather happy to get associated with this. We are certainly when I say we, my friends here, they do reside somewhere or other and the total concept, what is a total solutions discharge has been doing long ago, but now to see them in reality is what you just mentioned. I think your data, your presentations, your way And it is certainly must be, I'm sure, inspiring many others, including me. And I am just seeing the reality. And when we put up this plan, that our plan is about a large capacity, so our ground has been taken by salt manufacturers, but certainly they are the old heritage being still used by solar farmers. But now, in the backbone of this Tata Chemicals Limited belong some
Yes.
and then Nirma did it later on. So those things I'm also aware in extracting the magnesium, extracting boron, which is of our interest in that case, and including bromine. So all these things,
Bromine extraction.
bromine and boron, which is up to 5 ppm level. Only thing when as a desalination man, I see still as on today, not many seawater-based plants are there. Quite many plants in numbers, when I call them 500 plus. So quite many of them are traditional in nature, and where the variations are different. And to go into the real economics of recovering the salt from those brines from the drinking water plants, well, we both will do, and we'll get it the economics in a favorable manner. That's what I can say. I can assure you, sir. And all my colleagues who are here, I think all the we must clap for your presentation and your.
Thank you very much. Thank you.
Sir, I have a question, sir. Sir, I have a question for you. Sir, I have a question. Sir, it was a nice presentation. A lot of congratulations because you're really doing the work, which is meant for. So my question is that after having an IPR, do you file WIPO as well or you don't file WIPO?
WIPO, let me make it one thing very clear. We invest a lot of time, energy and money in innovating something. As far as WIPO or patent or intellectual property is concerned, it is only with one singular objective. And that is that, in India, once anything is successful, it is copied overnight. And we don't want to lose our business just because we have not been careful. So that is the only reason we go in for patents. Otherwise, there is nobody who is really trying to use it as an ornament or as a certification for themselves or them.
And secondly, supposing you were talking about like the X company comes and you
Correct.
develop a technology, and then the Y company comes. So in that case, so that is your property. You give the same. So in that case, you file the patent and you get the patent and then you distribute it. What is the process? I just want to understand.
It depends on case-to-case basis. So if you want a realistic answer, and if I'm not consuming too much time, and then for the younger generation, maybe it's interesting. We have a live case which is going on right now. We have an agriculturist who has come from Bihar, and he is one of those typical landowners, and he's got a huge makhana cultivation. But his son is educated abroad. He has new ideas. He doesn't want to continue like that. And he says, why should I sell makhana or fox nuts into the market? Why not extract the protein out of it? So if you recollect in my presentation, our Canadian unit is specializing in protein extraction. So that's the reason they came to us and they said, can you give us a solution? That I would extract this, because in the European market today, because of the vegan movement, there is a huge demand for vegetable proteins. So because of that, he wants us to work on this. Now at this particular point of time, as I am talking to you, we are discussing this basic issue. That if we find out something, then what happens? Suppose tomorrow I do a test, I show it to you that I can, and then you go to my competitor and say that they did it this way, this way, So it doesn't work. So yes, we have to find a legal framework under which we work. It starts with a non-disclosure agreement, of course, and then we have certain clauses by which we bind the person who comes to us. And obviously, one thing we take precautions, that is the finer details, and you have been involved in research, finer details of the real figures, calculations and other things, we are a little more cautious. Otherwise, the technology would evaporate from our innovation center before we even come to know about it. That's a reality. So, an intellectual property filing is always discussed with our concerned customer. And usually the customers are not interested. They are only interested in the commercial benefits that would occur from it.
And the applicant is your institution, and even if they become inventor, or even if they don't become an inventor.
If the institution spends money, it is institution's
I mean, you are the applicant.
Yes,
You are the
usually.
applicant, and
Either us as an institution or our managing director.
I mean, that is
Because he owns the
Oh,
institution
fine,
anyway.
fine. That is
Yeah.
there. And they can become the inventor if
Yes,
they are willing.
they are the intellectual property owners, and then my MD will assign the patent to us for commercial utilization. That is the way we.
Oh, fine. I really like your presentation, so I just wanted to have something.
Thank you very much, sir.
It was
Okay.
very nice. Thank
Okay.
you.
Thank you.
Thank you, sir, for enlightening us with impressive knowledge through your valuable session. On behalf of Dr. Chatterjee, sir, we would request our esteemed speaker to accept the memento. May I kindly invite Dr. Zeenat Arif ma'am to present a token of gratitude to our speaker. Now I request everyone to relish lunch. Sessions will resume sharp at 2:30 p.m. Thank you. Sorry, I request everyone to please settle down. Very sorry. For the next plenary session, we are delighted to have Dr. Naveen P. Sir. I would like to request Shagun to present his biodata. Thank you, Ms. Apova, for giving me this golden opportunity to introduce our next speaker, Dr. Naveen P. Sir. Dr. Naveen P. Sir has over 15 years of experience in process simulation, R&D, teaching and industry roles. Dr. Naveen P. Sir is a current manager of product development, specializing in process dynamic simulation for chemical, biotech and green energy, DCA simulation, AI-enabled simulation. Dr. Naveen P. Sir also led R&D and training at Oiltech, focusing on research and corporate training initiatives. Dr. Naveen P. Sir has also served as the head of Petroleum Engineering Department, emphasizing teaching and mentoring, and accumulated hands-on experience as a senior engineer in biofuel production. Dr. Naveen P. Sir has done PhD in technology, postgraduate degree in petroleum refining and petrochemicals engineering, bachelor's in chemical engineering, master's in applied psychology, and a diploma in industrial safety. Sir holds expertise in simulation model development, optimization, and training, and is skilled in teaching, curriculum design, and course content creation. Dr. Naveen P. Sir holds a strong background in research and development (R&D) for innovative solutions, in-depth understanding of biofuel production and algae processing. Dr. Naveen P. Sir holds a proven track record in business development and partnership building. Now I would like to request Dr. Naveen P. Sir to please come up on the stage and take his session.
Thank you for the beautiful introduction about me. Okay. An Elysian warm good afternoon to the regulatory and scientific community. I'm Naveen, representing our company Infosystem Private Limited. We are basically located in Chennai, and we came all the way from there to deliver you about the simulation. So the importance of the simulation and the need of the hour of the simulation right now for the students especially. So we can move on to our slides. So we do develop and simulate many models, chemical, especially the chemical plant models, and refineries, biotechnology, and so on. So we are the monopoly in India. There is no other company in India who develops dynamic simulations using the high-end coding technology. So our basic scope of the company is we do supply the simulation software to the industry. That is our core main job. We develop custom model based on the industry requirements. And this custom model can be for any kind of sectors, especially as I said, we covers refineries through 30 countries we reach. Our software they're using now. I will show that in details in the next slide. Please. Okay. To brief our profile, we have 100 plus industry that have been using our software for the OTS. OTS is nothing but the operator training simulator. If anybody wants to get into the plant, they must be trained in the simulator first. Okay. So without the certification of the simulation training, they can't let to work in the plant because highly the safety is the concern in the industry as well. Important. Okay. And 85 industries is being supplied, and more than 100 students has been assessing our software to understand the complexity of the industry's plants operations. And then, okay, so more than 30,000 students we trained, and more than 7,500 industry expertise has been trained in our software. That is our short profile of project. And, so key partners are not only we have our own software pro simulator. Not only that, we have been working with all the top simulation OTS companies, industries in around the world, like Ecogowa, the automation legends, and then BPT, the British people, and then the Norway company, and the Honeywell, and so on. So basic business model has been we are simulation development service for partners. That as I said, it is OTS, operator training simulator, and our custom model, any kind of service explaining about the SSP, explaining about the new innovation research. That also can be developed in simulations. Before running a plant, you can see what it is in the simulation, really. Because it will be easy for the students, especially because you cannot go down to the industry and you cannot touch the equipment and operate it. It will be pretty difficult to get an approval, and basically you are not eligible to operate it also because you don't know the process seriousness. And whereas in simulation, you can just operate and see the consequence of your operation. If it is proper, then the production will be perfect. If any problem occurs, it will give some alarm. You will have a tour on the simulation also. And standard models we have, and simulation-based training, we are providing training and standard models as well. Next slide, please. So I will take a short tour on our models, different kind of models where we are working about. Please go to the brochure. previous page, please. Okay, stop there. So as I said, we developed, we have a models for process control and instrumentation, basic process operations, refinery, gas processing, upstream operations, fertilizer, chemicals, petrochemicals, power and utilities, utility systems, metal processing, bio and food processing, and we have 3D models also, VR field operating suite, and simulator for AI projects, interface softwares, and we do develop the documentation, software licensing, training and support. So these are all our scopes of our job. Yeah. I will just take into your models list, a short models list. Please go forward. Okay. So in process control installation, so this is a standard model that we are providing to the students for the academics. Normally in industries we have big plants. In control system you have on-off level controller, temperature controllers, pressure controllers, and split train, several controllers you will be using in the industries. But you don't know how to operate it. You might be studying about the basic calculation about the control system, but you don't know how to operate it, because you don't have a chance to work on it. So, but in simulator, if you work, you can simulate and see the real effect of the operation of the plant. So simulation is nothing but duplication of the real plant. The meaning of the simulation is duplicating the real-time plant. That's all. So whatever you want to do in the plant, you can do it in the simulation. So it's like a pilot who wants to make a flight to ride. Before that, you have to get license in the simulator. So likewise, in industries, this is a license simulator for the operators exclusively. And then refinery operation suite, we have distillation, we have vacuum distillation, and so on. Many models we have, and we have gas plant operation suite, fertilizers, urea, ammonia, sulfuric acid, and this more. So more than 30 countries we supplied all these industrial simulation models, but we are customizing to a standard model to the academics, so that you can learn how to start up the plant, how to shut down the plant. Even it will take 1 day to make a startup procedure in the simulation itself. Likewise in the plant. And we have power and utilities operation suite, and we have industrial power plant operation suite. So more than 150 models we have covered in simulation plant model, which all being done for the industry's applications, and we are customizing for the students. You can close this brochure and you can move on to the next slide, please. So I want to take you to a short tour on a simulator, how it looks like, how it operates, a short tour. Okay, because I could not able to assess it here, so that I trained in to make assessment in a short while. So let's try the best. So this is the instructor station, and we have two stations, instructor station and operator station. In industry also, it's going to be like this. In industry, there's a general manager and senior manager or any supervisor, and there will be operator. For example, I am an instructor, I am a general manager, you people are the operator, okay? I will give some instruction to you. I need a production of 1000 kg per hour. Can you tune it? So the operator should go down to the plant. You have to tune all the parameters, increase the wall, operating things, equipments, heat exchangers, reactors, distillation columns, so that you have to achieve my task. So similar way the software also is being designed. This is a similar way we are teaching to the industry people also, for the operators in the industries. So this is the instructor stations. In the instructor stations we have many features. The important key features are snapshot. For example, all this model will take 1 hour or to 1 day, 2 day, 3 days also. It depends upon the density of the process. Because if it is a sulfuric acid plant, hardly it will take 2 days to start up the plant itself. Pump from the feed pump, and from the heat exchanger, boilers, utility, cooling tower, everything. In the simulator itself, it takes 2 days. So your time is very limited in academic. We know that. So you can take a snapshot once the time has been completed. So next day you can resume from where you left. yesterday. So you can continue for 1 month, 2 months, 3 months. When we develop the software, we don't switch off the system itself. It will keep on running day and nights. Next day will come, we will see if any parameters be changed. So we easily identify the problem and we can rectify in the simulation background coding. Such a way we are doing that. So you can close this. And the other option is malfunction. So in this instructor station, I'll be handling this. In the operator station, can you please open the operator station once? Just let them show how it looks like. Not the CS page. Yeah. So this is operator station. Okay. This you are going to handle this page. I'm going to handle the instructor stations. Whatever command I give in the instructor station, it will be affected here. Okay. And your task is to achieve the production rate finally. Okay. You can go back to the instructor station, IS. So there's other option, malfunction. So you know only the operator station as I saw earlier page. So I will be handling this page. Your professors or me, whoever may be handling this training section. So I can give some false malfunctioning. That means the pump 1 should be get tripped in another 5 minutes. You need not know about what is going to happen there. So after 5 minutes, the pump will get stripped. And you have to find out the root way how to address the problem. Because if any one pump gets stripped in the plant, it will disturb all the parameters. And it will cause major, massive problem to the industries. So how fast, quickly you are going to resolve the problem is the subject matter of subject here. So that will enhance your operating skills in the simulator itself. You need not to go to the plant and just to see the plant, oh this much make, this much scale, okay, but you will not go and operate it actually. But here in simulator, whatever the experience the operator gets, the same experience will be get in the simulator. That's the major additional value added things here. You can close this. And there is time running here, and about the time there was a green button, several green buttons are there. For example, since it's a dynamic simulator representing the real-time plant, since time is short for the academic people, you can increase the time 5 times, 10 times. The production also will be increased. Quickly you can see the results. That also is. But if you want to slow down the process and you want to keenly look into the actions, if any reaction is going on, nuclear reactions, if you want to focus on it, you can minimize the time so the simulator will run slowly. The study will be very appropriate to you. Okay. Then we can move on to, you can run the plant, we can move on to the next CS station now. Coming to the operator session, which is your sessions, you will be dealing with all these operations, real-time operations. You can go to the help, you can find the manual. In the manual, we have provided all the details. How to start up the plant, how to shut down the plant, what is the task for your students, activities task, everything is being given here in the manual. So this is normal operating conditions. For example, type controller, CTL is controller, tag name FIC, field indicating controller 001, and it is reporter field. The unit is meter cube per hour, scale low, scale high, and the design condition. So this is the technical details of the particular controller. Okay, if you operate beyond this limit, it will give some alarm. In industries, if you give any mistakes, it will give some problem. The equipments can be damaged. But here, you can observe the similar kind of damages. I will show you the things also. Can you go to the page? See the number 8. Okay. In 8, we have given students activity. So in student activity, you have to follow all this exercise in the operator station, so that you can understand the real process, technology, operating conditions, the real engineering behind the concepts, behind the simulation, everything you can understand. So you can close this. I'm just taking a glimpse on all these pages. since time is constrained. No. You can go to the CS station, okay? That's not been completed. So, for example, you can go and I'm going to switch off this now. Now dynamically the production is going on. Propane and butane is being produced here. This is a distillation column, binary distillation column, where feed is going. There are two pumps. Can you able to see the two pumps here? Okay, that is a feed pump which goes to the distillation column. At the bottom you can see the reboiler here, which is providing the heating source to the distillation column. At the top, the propane is coming. At the bottom, you can see the butane is coming out. So at the top, you have a cooler. You have to condense it and you can store in the vessel. Okay? So that's how it has been produced. And you have a reflex pump also here, and which is reflexing to the tank to maintain the purity of the product. And propane butane has been produced here. Now the operator has switched off this pump. There is no feed now, but still there is a fluid accumulated in the distillation column. Actually, it has to be separated. Now we are going to see what is the consequence being occurred. Go to the alarm then, the red color. Okay, can you mute out? Mute. Okay, there is no audio here with this. Is it audio is connected to this? Okay. Now you can see red colors indicates that what are the equipments got into the faults. Now you have to address all this because all the red mark shows that there is some abnormality has been occurred. Similar way it will be occurred in the industry. There is no change. 100% it is replicating the industry standard butane and propane distillation column. Okay. Likewise, 115 models we have. This is just a single unit. We have, if you take a distillation complete petrol productions or any diesel productions or any sulfuric acid production, it will go several pages. Unit 1, Unit 2, Unit 3, such kind of will be on moving on. Okay. Can you press the F4 button? In F4, this is called trend lines. Okay. Can you scroll it? This one, you can see the frequency. The bottom you can scroll. Okay. So you can see the frequencies, whether all the parameters is under stable condition. If any abnormality, it will show in the graph. There was an abnormality. If you scroll that. Okay, can you able to see abnormalities? So when the students switch off the pump, one of the pump, the main feed pump, what are the other parameters get disturbed? That will also be viewed here. So here it is given. What is the frequency of this everything? So in the graph you can see the overall disturbances in this graph. Okay, you can go to the F3. Okay, F2. So this is a control panel, grouping. It's called grouping. It's a control panel. In industry also they have this kind of DCS page because we are replicating the DCS. Do you know what is DCS? DCS, distributed computer system, because all the units will be in one control system. In a single control system, I can operate that chair, that chair, that pump, this pump, everything in one single laptop. In Germany, MD of a cement company operates his plant from his home, from his laptop. Just a control, wall opening, everything. He can operate the plant, everything from his desktop. So similar way, in the bigger industries, Reliance or any bigger industries, they have a DCS. So from one single system, you can open the wall, close the wall. If any abnormality, you can take an emergency control system. Everything is in hand only. The controllers, the process control engineers, who is sitting in the DCS room. So we just replicating this DCS in the simulation. That's all. Okay. So I'm just finishing my presentation on the simulation. Just I want to show you how this model has been developed, and we do provide the model development package to the academics also, because I am in charge of developing this kind of models, just replicating the real-time plan to the simulator, and we do provide the model development package to the students as well. You can close this and we can finish this. Model development packages. No, no, no. Go to the another PPT. Please move on. So go to the previous page. Previous. Stop it here. So this is how the controller will be. You can see the NASA people sitting here in front of the big screens and operating the satellites. Similar way, the DCS also will be operated like this in the industry plants. So we just replicating the similar kind of activities in the simulator. Please move on. Oh, please stop it. Previous page. So in chemical engineering, what subjects do you study? Heat transfer. What are the subjects you have? Heat transfer, mass transfer, and then? Okay. So what do you require to design a reactor? What do you require to design a reactor? Have you studied the design of the reactor? No? Rate kinetics, rate equations, okay? Material balance, energy balance, rate equations, rate kinetics, first order, second order, third order, pseudo first order. So these are all the terminology, equations which we study in the books. But how this formulas been implemented, used in the industry, you don't know. I mean, hope you can acknowledge that, right? Okay. But here in model development, we develop this basic equations into engineering applications to run the plant using the programming coding languages. During the training program, we will teach you the programming language also. So heat balance, mass balance, kinetics, momentum balance, phase equilibrium, plant design, instrumentation, and EST2 projects. Okay. Next slide, please. Okay, you can stop. So you know what is PFT, P and D diagram? You know PFT, P and D diagram. Process flow diagram, process instrumentation diagram. Okay. So this is very important to develop a plant, basically. Okay. So that also be thought, because before developing it, the complete plant should be developed in the PFD drawing, and then you have to implement the coding, and then the simulations will be developed finally using the programming languages. Okay. And then I close this. Last but not least, so everyone, all the researchers now, all the funding is moving, navigating to the AI development, artificial intelligence. Everybody is talking about the artificial intelligence nowadays, and it is not restricting to us. We are also into the AI development using the simulators. What is the basic you require to develop the AI? Basically, what you require to develop the AI? What you need to develop the AI? What do you want to develop the AI? Data. Okay, it's not just a data; it's a big data. So in the simulator, when you start the plant, there is an option in advanced training. You can start recording the plant operations. Each and individual students can start your recording of your operations till the end of the operations. Okay, and so that finally, when you complete the process or the production, what the task we are giving to you, then you can stop the recording, you can generate the data in a complete Excel format. And it will give a graph also, how you performed everything. Can be generated in the software. Okay? So it is a big data. It's not a single data, it's a big data because there are many parameters, different indicators, controllers, kinetics, engineering, distillations, separations, production rate, everything's there. Everything can be recorded. Okay, all this recording will be stored in Excel sheet. That is a big data that be provided by the simulation. So you nowhere you will get the data from anywhere in the market. Because if you go and knock the industries, ask for the data, they won't allow you. If you go to the journal, search for the big data, there is no availability of the production data. Only the simulator can provide you the big data. So this big data, we will take it into the AI enabling system of the simulator. And real operating data will be produced by the simulator that can be stored in a system that can be converted into a machine learning that is called neural network. This machine learning, we have been working with the data set, data augmentation, and data splitting, training, such kind of activity we are doing, data splitting, and using this long-term memory, long short-term memory, gated recurrent unit, LSTM GRTU. We have been working on that to develop the AI enabling system for the simulator. So that's how our IR 4.0 we are working on it, Industrial Revolution 4. So we are the monopoly in India. There is no other company working in the simulator, working in the AI enabling simulator in India. If you want to go for the simulator, you have to go to the US. Nowhere in the Asian country, we are the one and one company, we are working on the simulator. More than 30 countries, I can say more than 60 countries, they are operating on simulator, using a simulator. From Japan to the US. So we are working with Norway, Sweden, Netherlands, USA, and in all the Arab countries they are using our simulator, and South Africa and India. In India, all the refineries, especially the government companies, ONGC, IICHE, and we are working with Baba Atomic Research Center nowadays. With the reactor, nuclear reactor, we work with simulators. Because they came down, they searched for us, we don't propose them. They searched for us, they're searching for an Indian-owned company. Because it is a confidential work for our nuclear power plant. So this is how we are reached so far in the market. And for the academics, more than 100 institution students, more than 30,000 students has been trained here. Because this software, no company will provide for the students. Because this software is meant for licenses for the industries. Only for the industry operators, supervisor, engineer. If any, recently IFCO people came down to our office. You know IFCO, right? Indian Farmers Fertilizer Company. They came down to our company, they stayed there for 10 days. I was training them in a sulfuric acid plant because they newly installed a German technology plant, sulfuric acid plant. They don't know how to operate the plant. But we already did that technology for the South Africa plant. So they came down, they completely operated for 10 days. And they went back, now they are operating this German technology sulfuric acid plant in IFCO. So such a way we have been established our business throughout the nations and throughout the world. And our mission is to bringing this industry to the institution. That is our caption. Our caption is bringing industry to the institutions. That is our captions. I think, hope I can conclude this now. Thank you so much. If any question, please ask. I leave this moment for questions. Okay, then, thank you.
We expect that students should ask more and more questions because inquisitiveness और जैसे हिंदी या इसमें की जिज्ञासा बोलते हैं वो आपके अंदर ज़्यादा होनी चाहिए और I just would like compliment you by being part of this our InDACON 2025. Number one, number two, this your mission and caption which you said, being a part of the say institutions, you know, And I have been just telling, attending many things, what is happening, just like, previous speaker was trying to speak on that something which is working on little bit, on a commercial scale, they have to survive because where institutions are mostly in a non-profit organizations. But we as an industry of small scale or medium scale cannot survive without if it is say negative profit. So seeing both the things, but there is a one thing which is there, what you call a bonding between institution and industry has always been the case, that how to bond better and better. I only thing wanted to bring to notice of both of you that being a member of All India Council of Technical Education, where in year 18 and 19 when I was a member there, rules have been now made that BTech student has to undergo approximately 400 man hours of industrial training before they could be given the certificate. Now, in this case, where you would like to go or where you will opt to go for industrial training, and which industry is ready to accept them for the training. So in both the, say, someone is looking for and someone is ready for it. So there I must thank you for that, your offers, and I must wish to share with the students, please, if you have to become real, true, what we call it, chartered engineers. There is another word which is being used in British era. The chartered engineers. Chartered engineers like practicing engineer, is it not? So, although you miss, when I say you miss me as well, so we have do undergo to some practicals or labs during the 4 years of the course, or maybe 3 years of BTech courses, but that's not sufficient. The scale of operation in the pilot plant which Mr. Banerjee was trying to speak on, so that is too small, and it is something even little bigger than where you can all parametric study can do, and you can scale up to commercial scale or semi-commercial scale for the next stage, which is production. So in that situation, your undergoing to the training is important. So not only from, I must thank to SSP team as well as the SIM team here who are here to be a part of the our InDACON 2025, and please take the advantages of this. So at the same time, the kind of directions they are giving you, which often if an academician is making a presentation, you will find that their cost factor is totally missing. Whether it is a case, you can take it from Madhu Agrawal madam, or you can take the case of what Chaursia madam. The cost factor is totally missing in their presentations. There is ideas are there, concepts are there, but what will be the cost of that treatment total? Because being from academic institution, cost will come when we will go for commercialization, or cost will come when we think of the commercial part of it. But my dear students and sir, it is a finally what plays the role is a cost. Engineering is not complete until it comes to something where it is a sellable, and when you say sellable at the cost which is a profitable. So not only your own knowledge, your own ideas, concepts, everything, plus you have to convert that knowledge and concepts into a 3D productions, and then you can serve them in that form. So nowadays, as we know, both hardware and software goes together. Whether you are serving softwares, which is inherent into the system, or it is a hardware which is visible. So I think so many examples nowadays are there where software is being sold and it is worth many, many lakhs. So I think both the things it works. When I say software, I think you all understand very well because you have been brought up in those era of softwares. Well, we were not in that, but nowadays, yes, softwares are there. I was in the era of slide rules, which came the calculator in 70s, and later on now I am working with the supercomputers as on today. But started with the slide rule. So a lot of changes, water has flown into the system, designs, from science engineering to the technologies that are available here nowadays. And to conclude my just this statement complimenting these two gentlemen whom I am meeting for the last 2 days, and also the team which has come from SSP, that very important is there that whenever you try to do something, and at the end you must think that how I am going to conclude, and suppose you yourself become an entrepreneur, using your own concept that you have been trying to work, whether it is going to feasible, I'm sure you will find that yes, lot many out of the things needs to be done further in the same, and I'm sure those bridges you'll get, and then next stage comes there, and next stage of the softwares and many more things will be coming from other fields also. So I'm sure please enjoy this. I think that almost we are on the third day, and I must thank on behalf of Indian Desalination Association for all the industry who have been a part of this, and all the say organizing team who are the mostly my Hercotians team, and so probably maybe I'll be here till the variety function as well. So we'll try to talk more. Thank you very much. Thank you, sir.
सबको नमस्कार. Thanks sir, and ये जानकारी आपको देने के लिए प्राउड मूवमेंट. ये सॉफ्टवेयर है ना हमारा प्रो सिमुलेटर, एक खुद का हम बनाया है चेन्नई में. मेरा कोलीग रामन जी वो आर्किटेक्ट दिस सॉफ्टवेयर पूरा 60 कंट्री से यूज कर रहा है प्रोसेस एंड एनर्जी इंडस्ट्री में. The true Indian intelligence has proven to the globe. More than 100 plus engineers are working for our team, the global operations. So our goal is that to bring this into our classrooms, make you all ready for the digital revolution happening in Industry 4.0. Ours is the only software which gives the digital data. It is accredited by the Ministry of Education, Higher Education, and we signed MOU with Government of India, IICHE. 3 साल पहले हम साइन किया था. मतलब क्या है? So we want to give this to our students पूरा देश के लिए ना with the very lowest price. Very lowest price. It is approved by the IICHE, and even still आप देख सकते हैं. सब बोल रहा है ना प्राइस का बारे. हम ओपनली बात कर रहा हूँ. नीट में नेशनल एजुकेशन अलायंस टेक्नोलॉजी 2 पे आपका हमारा प्राइस है ना वो पूरा रिफ्लेक्ट हो जाएगा. वो प्राइस डिटरमाइंड बाय द पीएमओ ऑफिस इटसेल्फ 3 साल पहले. ये इतना मेहनत करके जो टेक्नोलॉजी लेके आ रहा है ना, ये टेक्नोलॉजी इसे खुद का बनाया था आत्मनिर्भर कंपनी. एंड द प्राउड मोमेंट एंड आई टू सी ऑल द ग्रेट केमिकल इंजीनियर्स, द ग्रेट इंडस्ट्रियल एक्सपर्ट्स हमारा देश के लिए. एंड सर वाज अ रियल इंस्पिरेशन, वाज रियली मेंशनिंग दिस इंपॉर्टेंट फैक्टर ऑफ द प्राइस. ये फैक्टर को मैं आपको भी बता देंगे. सो हमारा देश में ना दिस इज ओनली यूनिक सॉफ्टवेयर, यूनिक टेक्नोलॉजी which is the very base for the AI engines and ML. पूरा आप डेटा खींच सकता है, यूज कर सकता है, and you all be ready for एक आखिरी एक जानकारी दे रहा हूँ. हमारा देश में ना ये बीटेक केमिकल इंजीनियरिंग इनका महीने का सैलरी 4 लाख है. हमारा देश में, विदेश में नहीं. किधर चल रहा है? हमारा क्लाइंट है ना यूनिवर्सिटी ऑफ पेट्रोल एंड एनर्जी स्टडीज हजारों केमिकल इंजीनियर उधर पढ़ रहा है. They have a complete establishment of a dynamic simulation pro simulator, along with great visionary of the management and the great faculties to embed the AI over on it. So the industries are queuing, and especially uniformly for the girls and the boys. I'm telling. People are hesitating, girls will be hesitating, know about the chemical engineering, वो इन लोग क्या मना करेगा, वो industry ऐसा है. You people are required for this new generation innovations. So we are coming from Chennai. We know how the new generations have been welcomed with this exposure of this technology. So after not only students of University of UPS, even those institutions who are associated with us, and we make as a finishing school and make them ready for the. हमारा देश में ना अभी पूरा विदेश कंपनी का एस्टैब्लिशमेंट चल रहा था. They come and recruit to the institution who are having this kind of finishing school. Yes, maybe इतना एक आशा करता हूँ, मेरा भी इतना रोशन है, इधर भी हो सकता है. हम पूरा है ना हमारा देश का हमारा खुद का इंडियन का केमिकल इंटेलिजेंस ऑलरेडी अप्रूव्ड है. हम बहुत आना चाहिए. आप लोग के है ना सिर्फ जॉब का काम का भी नहीं है, इंडिविजुअल का एक एंटरप्रेन्योर का हम देख रहा हूँ. You all become an entrepreneur, especially this is an era of AI, as I was mentioned, and ML. तुरंत आप यूनिकॉर्न बन सकता है, तुरंत बन सकता है, ज़्यादा दूर नहीं है. So you got the opportunity, and InDACON has brought all this great platform, and sir was briefing about the expertise of industry, research and all. So you are all very much gifted. So yes, we will be backing with you. आपका सबका dreams इतना बड़ा आएगा. So you will be all in the flying colors. So I wish you Jai Bharat Mata Ki Jai Hind.
I think just he gave one dimension, so I think before we disperse for the lunch, see, mostly when we try to do any simulations and which era and which area, that simulation is a prime most, and without that we cannot move ahead. I think most of you may be reading in the newspaper or listening on the TV news, space research going on in India, and the achievements of space are ISRO. Okay, me means I am also a part of the same group of industries, our DA family, out of which the ISRO has come out. So we were taught here in MTech first year, I remember very well, there's a card something CPM and PERT way of project looking at. So CPM and PERT techniques, we apply PERT techniques there in a space where not many uncertainties prevail. But we do apply a CPM techniques for completing the first, reducing its gestation time, bringing it from start to say the commissioning and start the production. And how we can reduce this journey from through CPM studies and reduce the total gestation time, and which sometimes used to be maybe in 14 years, 15 years, then now we have brought down to 3 years, 4 years, like that. And so this simulations, before investing crores and crores of rupees, saying the satellite, then nothing in your hand, everything by remote, triggering the things, first stage, second stage, third stage, now gone that orbital. Everything we are trying to do from the earth, not flying behind just like Hanumanji, behind that satellite. We are not doing that. We cannot capable of doing that. So we, with our mind of simulating what has been developed by many industry, it is your mind to develop softwares, and that's where softwares becomes in a present era, and every transport like CFD is becoming, a buzz of words. Then only can think of very complex problems also. Which I am selling CFD, it can be used for molecular nano level of injections, in the pharma industry and in therapeutic purposes for medical applications. Anyway, so this we can continue talking on the same. I think organizers are just please waiting. Thank you very much, please. Thank you.
Thank you, sir, for enlightening us through your valuable knowledge. To express our heartfelt appreciation, we would like to felicitate our esteemed speaker. I would also request Dr. Raman sir to come upon the stage. May I kindly request Dr. Shravan Kumar sir to present a token of gratitude to them. Thank you, sirs. Thank you all for your enthusiastic participation. Now I request all of you to please relish the lunch. We would resume our sessions by 3 p.m. sharp. Thank you.
College, Jalandhar then, and now Dr. B.R. Ambedkar, National Institute of Technology, Jalandhar. He has joined a permanent position of teaching in October 2021 at SBSCET Firozpur. He has published 30 research papers in SCI index journals, granted 3 patents and applied for 2 patents. He has successfully completed a sponsored research project of worth rupees 1.77 crores from ONGC. He is actively contributing to the area of novel energy resource, that is to say, gas hydrates, biohydrogen, carbon dioxide, capture and sequestrations, flow through porous media, flow assurance, waste to energy, biomass valorization, pyrolysis, biomass gasification, applied microbiology, microbial concrete, biocoal, sustainable coatings, human implants, water and wastewater treatments, etc. He has successfully guided 6 PhD students and 4 PhDs are going under him currently. He has given many plenary talks at reputed international conferences and has chaired sessions at many reputed international conferences, including ChemCon. He has delivered 35 invited talks at various prestigious international and national institutions. Dr. Arora has organized many FDPs, STCs, and conferences. He was member of Scientific Committee of second edition of the 12th Conference Young Scientists in Power Engineering YPE in 2020 at Wrocław University of Science and Technology, Poland. He holds a membership of Indian Institute of Chemical Engineers, Indian Society for Technical Education, and Punjab Academy of Science. His and his students' research work has been awarded as Best Paper or Poster Awards at many international conferences by many reputed bodies like Indian Oil R&D, ONGC, CSIR, Ministry of New and Renewable Energy of India, along with Springer, MDPI, Switzerland, etc. His international collaboration and research publication for research work include many reputed institutes around the globe, like Imperial College London, United Kingdom, King's College London, UK, University of Leeds, UK, University of Liverpool, UK, Teesside University, UK, Technical University of Denmark, Wrocław University of Science and Technology, Poland, National Oceanography Centre, Southampton, UK. And now I would like to request Dr. Amit Arora sir to please come up on the stage and take a session on thermodynamics and kinetic study of methane hydrated as a novel energy resource.
Thanks a lot, dear Shagun, for such a nice introduction. And I really thank the organizer of this conference, especially Professor Shastri, for the. And here today, I'll be talking about a novel resource of energy. This is how my institution looks like actually. So here I'll be talking about a novel resource of energy, that is methane hydrates. Actually, their amount is double than the fossil fuels. Anyways, my talk has been divided into 3 areas. In the first area, I'll be talking about the introduction part, so that we get we get to know what are methane hydrates. And then I'll be talking about the experimental studies which were carrying out in our laboratory. And then third, I'll be talking about that we don't have as of now any of the technology available in the world for their commercialization. So I have gathered some sort of data, some news, some current sort of information in which we are confident that very soon we are going to commercialize this resource of energy, but currently we don't have any technology. Anyways, cutting short, I'm talking about here I'm just talking about that be it any conventional resource of energy, so these fuels, be it gas, be it petroleum, all of them, they are going to be depleted because they have a specific age. Now, you see, moreover, we are going to shift our economy towards a gas-based economy. In the timings to come, we are looking for an economy which is a gas-based one. So here, we are talking that the methane hydrates are worth well investigating, and moreover, there is no chemical reactions, there is no chemical bonding. There are 2 molecules, one is a host and one is a guest. What happens actually, the gas molecules at a suitable conditions of temperature and pressure, they start making cages, and then the host molecule goes inside the cages. For example, if you take particular temperature, that has to be low enough, and if you take a high pressure, that has to be high enough. In that case, what happens? They start making cages, and the water starts forming like ice, and the gas goes inside those kind of cages. We are having certain kind of voids in the cages, so we are having certain kind of empty spaces. On those voids, what happens? The gas occupies those places actually. So this is just nothing. It's not of. It's just an intermingling of compounds only. Here we are talking about, you see, if you are talking about this global energy demand, you may see as we are moving from 1919 to 2040, you can really see there is a portion of gas, the gas-based economy are coming. Here you can see the renewable are rising, the nuclear is rising, if you see the natural gas is rising, and then the oil is there, oil, coal and wood are depleting. So that means slowly, we are moving towards the economy which is a gas-based one. So in this context, it's very vital to investigate methane hydrates as a potential energy resource candidate. Here again, I'm talking that why we are here, why this is the agenda of the day. Agenda of the day is because of the two factors. The one is the energy and one is the environment. You see, we are worrying that we should get some resource of energy in the timings to come, because the fuel will go, because the oil will go, because the coal will go, and the natural gas which you have at the moment, they also have an age of around 50 years. The second worry, which is the global worry, is because of the carbon footprints. What happens actually? Slowly, what is happening? The CO2 is rising, and because of this, the global warming is happening. So that means we should have to investigate a resource which can supplement the fossil fuels, and side by side it should emit lower carbon dioxide. So what this slide is speaking? This slide is speaking, if you see over here, the natural gas is emitting the minimum amount of kilograms of carbon dioxide per kilowatt hour. So the resource which we are going to talk about in few minutes to come is going to substitute the petroleum, is going to substitute the natural gas. Side by side, it will emit only the least carbon dioxide into the environment. So that again makes this candidate as an ideal candidate in the current context, where there is a lot of worries for the energy and a lot of worries for the environment are there. So this is a potential candidate to talk of. That is why it is the agenda of the day. Here I am saying, why gas-sided? Because of their huge quantum, they are cleaner, they are greener. You see, if we compare the age of the, if you talk about the global reserves and the production ratio, you see, it is showing that the oil reserves are having on the age of 50 years. If you talk of the RP ratio, of the gas, it's again of 49.8 years. If you talk of the coal, which is currently we are not preferring because of the global warming, but still, we have a coal of around 132 years left. So that means we must talk of today an ideal candidate, that is gas hydrate. You see, another thing is this, that the gas hydrates have a tremendous reserve and their carbon quantum is double the fossil fuel. Here I am talking about, if you talk about the recoverable and non-recoverable both, I'm saying both, recoverable and non-recoverable, because we know that the oil is there, we know that the coal is there, we know that the gas is there, but we don't have any technology to many high pressure reserves, many high temperature reserves, we even don't know how to exploit. But even if you count them, that they are exploitable, even then the quantum of gas hydrates is double. So that makes this candidate very fantastic. Now, if you talk of the energy potential, none of the candidate, be it renewable, be it wind, be it energy, be it solar energy, be it wind energy, be it any sort of energy, none of the candidate can compete with the gas hydrates because of their huge quantum, because of their greener and cleaner resources. And if you see, if you talk of the US is saying, if you are only able to exploit 1% of the methane which is there with the gas hydrates, then it's almost double the supply of natural gas in the country like America. That's again fantastic. Again it's saying the coal, again I'm reminding you that the age of the coal, natural gas and the fossil other fuels are decreasing. Again, we are saying the point is this: lot of countries, lot of agencies of oil and gas, they're coming to India. Just because of this, the Indian gas hydrates are very much shallow. They are exploitable. This is first thing. Second thing is this, that their quantum is too much high. If you can see over here, this slide is saying that India can provide a gas hydrate which can have a usage here of minimum 34,000 years around, and then maximum about 2.5 lakhs. That means 2,66,000 years. So that means alone India can give you energy to the world to this much amount of year, where no worries if we are able to exploit this resource. But currently we don't have any technology to exploit this resource actually. But India can give a world energy for around 2.6 lakhs of years. I'm saying their signatures are there. They are available around the globe. They are available everywhere. They are available in the Gulf of Mexico. They are available in KG Basin. They are available in KK Basin. They are available in Japan. So they are available in many trenches. So if you see over here, I'm talking about two dots. One is the yellow one, and one is the red one. So the red one are the inferred one, and the yellow ones are the proven one. So they are available around the world. They are available in almost in Canada, in America, everywhere they are there. If you talk of the Indian context, we are having in the KG basin and we are having in the KK basin. So we are having the thickest one in the Andaman Sea and the richest one is in the KG basin. So this is how the Indian context it is. Now, they are cleaner because the thing is this. The first thing is this, that I have already discussed it in the beginning only, that they are giving only minimum amount of carbon dioxide. Only 0.24 kilograms per kilowatt hour is emitted. So that is the least one. Another thing is this, what we're doing in our lab is, or what we're doing with the hydrates in many laboratories is that we want to exploit this resource of energy through CO2 sequestration. So if we are successful, in that case we can, solve the two burning problem of the globe, that is the global warming, that is the environment and the energy. So we will be getting this resource of energy, vis-a-vis we will be reducing the global warming. Why? We will be putting the CO2 into the sea, into the reservoir of methane hydrates. So the hydrates of CO2 will be formed and the methane will be coming out of the reservoir. So means both of the two problems which are worrying mankind for since ages, they'll be solved simultaneously. So that means they're cleaner and greener. If you see, this is the structure which I'm talking about. Here the water is a host molecule and the methane is a gas molecules. And the methane has occupied the white spaces which are available once the cages of hydrates has formed. They only form when simultaneously high pressure and low temperatures are there. And these kind of conditions are naturally there in the permafrost region and in the reservoirs in the sea. In the sea basin also we have these sort of conditions. So we are having hydrates in two places. One is the permafrost region, another one we are having in the sea basins. So that means they are there. Well, once we fabricate into the lab, we fabricate into our lab, so you can burn them. So that is why it is called burning ice. This is why, because you have the methane hydrate, you can burn those sort of hydrates. After making, we can burn them also. So this have all been discussed. They are cleaner fuel, and their global occurrence is making them ideal. This has been discussed. There are other names. This is burning ice, white gold, or SNG. That is solid natural gas. This is the slide actually. This slide is the methane hydrate only. So this is the structure of the hydrate in this slide, and this is how we can burn them after making. So this slide is depicting the structure of the hydrate only. This is how once we fabricate to the lab, they look like this. They look like only ice, but then there are many other signatures. With the help of many other techniques, we can quantify, we can characterize them that they are methane hydrates, but they are not ice. Now, the interesting point about the hydrate is, this is the one part which I will be discussing today. However, hydrate is not only the energy candidate, they are technology. You see, we are using them for the transportation of the natural gas. You see, in the coming time, the natural gas is not going to be transported like in cylinder, like in pipeline, we'll have hydrate based transport. Then you can have separation of gases. For example, you have gas mixture. So every molecule, every gas has its specific temperature and pressure conditions to form the hydrate. So you will provide the CO2 methane hydrate formation condition, CO2 will be formed, and if it's a mixture of methane and CO2, this is what we are doing with the natural, this is what we are doing with the methane biogas plants. So the only thing is that in the biogas plants, what happens, you have a biogas which is CO2. CO2 is the culprit there. So we are inventing a technology where after forming the biogas from the solid waste or from the municipality waste, we'll make the natural gas, and from the natural gas, we'll provide the conditions of the methane hydrate formation. The methane hydrate will be formed and the CO2 will be separated. So this is one thing about hydrate. Hydrate is a technology these days. You can use it for the carbon capture. Then you can use it for the water desalination. So what will happen? Once you have the water desalination, the RO type of plants. So over here, what we'll be doing is we'll be providing a hydrate formation conditions. So at that time, when the hydrate will be formed, afterwards when you'll be dissociating the hydrate, only pure water is going to form the hydrate, not the impurity. So then you can have a desalination of the hydrate through this desalination of the water through this hydrate formation technology. So that means hydrate is more or less as a technology these days. It's not only the energy candidate. They can be used for many applications which this slide is depicting. Here I've already talked about that the gas is a host molecule and water is a gas molecule. So every particular gas has a particular hydration number. In case of methane, the hydration number is around 5.75. Here we are talking about quickly that there are three structures: structure 1, structure 2, and structure 3. So they are depending upon the cavities. So the structure 1 is having different number of cavities, structure 2 is having different number of cavities, structure H is having different number of cavities. If we talk of structure 1, it's a cubic. It has around 2 small cages of 12 pentagonal surfaces called 512. Then 6 large cages, then 512, 62. Then it contains 46 molecules of water. So this is what I'm talking about. It's not working. It just yes. Please next slide. It's not working actually. Next slide. Yes. Here I was talking about this is 512 pentagonal dodecahedron and this is tetrachide dodecahedron 51262. Here it's structure 2. Structure 2 is again having 6 small cages, and this is called 512, and 8 large cages, which is called 12 pentagonal and 4 hexagonal. It contains 136 molecules of water. This is how it looks like. Structure H, it is again having some 3 cavities and large cavities, 2 small cavities, and then again 1 large cavity. This is how structure H looks like. Then period first one, it was a curiosity. Period 2 is the one when it is a problem to the natural gas industry. It was invented as a problem. It was invented as a nuisance actually. So what happens? And the pipeline used to, they were bursting because of hydrate formation. Because when the natural gas was getting transport, what happens? So there are certain kind of areas where automatically the low temperature and high pressure regions will come. At that point, the hydrate will be formed, and because of the downhole and the upstream and downstream, there is a lot of pressure variations because of the hydrate formation. They will be blast into the pipeline. So they were never invented as an energy resource. They were invented as a nuisance only. But then in the period 3, they were invented. This was thought that these kind of conditions can exist anywhere. So these kind of conditions are existing in the permafrost, and they are existing into the sea basins also. So that is why many reservoirs were investigated, and fortunately we got those kind of resources which I have shown you in a slide, where we have talked of both the resources, the inferred one and the proven one. So there are 3 kinds of classification. This is class 1, class 2, class 3. Class 1 is having when down the hydrate you have a gas and water both. Class 2 is the one where the absence of gas is there. You are having the hydrate and beneath there is a water. Class 3, which is the absence of anything. Only you are having the nodule of the hydrates. There is no presence of water and there is no presence of the methane down the hydrate. This is the negative side. That's what I'm saying. That I have already discussed. That what happens, this is the nuisance. They are not only the energy candidate, but they are having negative side as well. So you can see over here that these kind of gas hydrates are found into the oil and gas pipelines, and because of this, lot of threat to the life, lot of threat to the environment, a lot of threat to the machine man that happens. And oil and gas companies have to spend trillions of dollars in order to avoid the gas hydrate formation into the natural gas hydrate pipelines. So there are many techniques. So this is thermal simulation. I just take the help of a diagram because I've been instructed to finish in time. So that's why I'm just taking help of diagrams only. Anyways, over here you can see it's just nothing. It's just a thermal injection. It's no high science, but it's very tough to do when you do it in the reservoir. Only you are injecting some thermal. You are injecting steam. So what that steam will do? Once that steam will be going to the reservoir, only thermodynamically they are stable at high temperature, high pressure and low temperature. So that steam will rise the temperature beyond the stability temperature of the hydrate in the reservoir. So the methane will automatically start coming out of the reservoir because of the reason the temperature at which it is not stable. It's very simple, I guess. Here, again, the next is the depressurization. I have discussed that they are stable at high pressure and low temperature simultaneously. So it's going to do nothing. You're just going to drill a hole into the reservoir. So the moment you will be drilling a hole into the reservoir, it will be coming out of its stability zone. So that means the condition of last time you increase the temperature, this time you decrease the pressure. So you have to do nothing. Only you have to just create a hole into the reservoir and the methane will start coming out of it. But then towards the end of my presentation, we'll discuss it's not that easy. Because in the beginning only I have told that we don't have any technology as of now which can be commercialized. If we are able to tap this, India is gonna see another economical, it will be leading the world actually in the times if we are able to exploit the hydrates. Because the reasons I have already told you, that they come on quantum and they are very much exploitable because they are present very shallow beneath the sea. So but then we don't have any technology. It seems so simple, but it's very complicated when you go to the real high gas hydrate sites. Then this is inhibitor injection. It is the same thing. Mostly we use it for the inhibition. Seldomly we use it for the exploitation. We put certain kind of kinetic inhibitor. We put certain kind of thermodynamic inhibitor. Where thermodynamic inhibitor, they huge quantum we need to put. We put methanol and these kind of compounds. They will inhibit the gas hydrate formation, and they will, mostly they are not used for exploitation. These sort of inhibitors are used to inhibit the gas hydrate formation to the gas hydrate pipelines. Now this is the technology, which we'll be talking. Here we are talking about nothing. Here we are designing a technology into the lab where we'll be putting CO2 into the reservoir and we'll be getting methane out of the reservoir. How? Because hydrate formation is an exothermic phenomenon. So what will happen? The moment the CO2 hydrate formation will take place, it will generate an energy, and that energy will be more than which is required to dissociate the methane from the reservoir. I'll take a help of a chemical reaction. You can see the CO2 is going into the reservoir, and the hydrate formation of CO2 means CO2 hydrate will form into the bed, and you will be having methane out from the bed. So that means hydrate of CO2 will be formed. That will be solving your global warming problem, and it will be giving you methane out. That will be solving your energy problem. How it happens is, you can see over here, once the methane hydrate formation will take place, it will generate around 57.98 kilojoules per mole, and you only require 54.49 kilojoules per mole to dissociate methane out of the reservoir. So that means what that thermal sort of steam etc. was doing, they were also giving energy only. That energy will be given by the reaction itself, because formation is an exothermic phenomena and dissociation is an endothermic phenomena. So over here, the energy which is provided while formation of the CO2 hydrate formation is more than the required energy to dissociate the methane out of the reservoir. So means it is very, very much enjoyable sort of condition. But over here the efficiency is a bar. So now we are trying like this, that straight from the reservoir, the energy to the grid will come straight from the home. This is the model which the many nations like US, like government of India, the Japan, the Germany, they all are trying for this actually. Then the grid to the grid state. This is the diagram. We'll be putting CO2, that sequestration we have studied to the last slide. Here the methane will come, it will go to turbine, it will go to generator, from the generator it will go to transformer, then it will go to the grid, from the grid it will go to the home. That is what is there, the agenda in the mind of the scientists and the policy makers. It is there at the moment. Only thing is this, that their exchange was possible because they both form structure one. That's why I took a help of little bit of structure there as well. However, it's very difficult to discuss many things in the around 35 minutes, But still, I've shown you the structure. Their exchange is possible because both of them form structure one. If the case would have been that one is structure one and one is structure two, then the exchange was not possible in that case. Here, you can see. Now I'm moving toward my experimental study. I'm talking about, today I'll be talking about how the, biosurfactants are getting released at the natural gas hydrate sites, how they're forming actually. And then what we are doing is over here is, once we are creating certain kind of vessels, we have vessels also, we got the patent also by designing the vessel. But it's very tough actually. Every time you cannot go to the real gas hydrate conditions because it's a lot of money. So what we do, we form the methane hydrate in the vessel, then we dissociate the methane hydrate in the vessel only. So while doing like this, over here we are proving that why they are not getting formed at every place. They are not getting formed at every place is because at the natural gas hydrate conditions there are certain microorganisms like Bacillus subtilis, like Pseudomonas aeruginosa. They are generating biosurfactant over there, and those biosurfactant are responsible for forming the methane hydrate at that particular sites. So over here we are not taking help of biosurfactants in the vessel. In the vessel we are taking help in order to increase their formation. We are taking help of some kind of synthetic surfactants like sodium dodecyl sulfate, like these kind of synthetic surfactants can increase their formation. But we have proven this, and we have published this with this paper with the Nature group. We have proven it that they're getting formed at particular sites just because there are particular kind of microbes and they are generating those kind of biosurfactants, and that's why they're getting formed over on that particular site. So that's why I'm introducing the biosurfactant. So these are epiphilic molecules, water loving and fat loving. So this is the lipophilic one, the domain one, and this is the hydrophilic one. Here, these are the microbes, the Bacillus subtilis and the Pseudomonas aeruginosa. They have been identified Gulf of Mexico. Gulf of Mexico is one of the proven resource, gas hydrate resource, reservoir. So they can always. Another thing is this, that why we are talking about biosurfactant is they are very much because I have already discussed in my slide that this time we are not observing them as a energy potential candidate. We are observing them for many applications like CO2 capture, like hydrogen storage, like gas separation, like transportation of the natural gas, like water desalination. So that's why if these becomes reality one day, so in order to speeden their formation, so you see in that case we are using synthetic surfactants. So but here in this study we are providing biosurfactants that if they tomorrow becomes a reality, if the gas transportation by hydrates becomes a reality, if the gas storage becomes a reality by hydrates, then in that case we won't be using the surfactants, we'll be using the biosurfactants. So that is what this slide is talking about. That's all. That's it. There are very few studies over here. Now I'm switching into the interest of time. I'm quickly switching over to my experimental study. This we have experimentally proven, and this we have published also. Here we are taking some strain. That strain we are generating granulolipid. Once we generate the granulolipid, we characterize it using all the technique like NMR, like LCMS, like MALDI, like PLC. That is commercially. Giving all the signature that is granulolipid. So that granulolipid we are using in some fixed bed media. We are using without fixed bed media. Let's say we are having water and methane, will form the methane hydrate. We'll put that only water in the fixed bed media. That's the second study. Then we'll be varying the dose of the biosurfactant in the media. Why we are taking help of media is that if you don't take the media help, in that case, the stirring is required. But then stirring is very energy intensive. In order to replace the stirring, what happens? We are trying to form the hydrate in the pores only. We'll take the media, we'll get the BET done. From the BET, we'll have a value of the pore volume. And then using the pore volume, we'll optimize that how much saturation is required. That's a very tedious study. Saturation is sometimes these studies carry at 90% saturation. So then we'll be forming the hydrate in that fixed bed media, because if you form on water, then you need stirring. Because if you don't do stirring, then there will be cut off the gas from the surface. Only the gas cannot go inside, because the hydrate will be forming on the surface and the connection of gas from the beneath surface will be cut. So that's why you need the stirring. But then stirring is very energy intensive. This is another finding that we have investigated. We have given the fixed bed media that tomorrow if you want to use it for gas separation, for transportation of natural gas, for water desalination, then the hydrate based fixed bed media will be preferred, because if you form them with stirring, it is energy intensive. So this is how the bed is formed into the reactor, and then we'll be having the methane hydrate. This is the experimental program of the study. This is what I'm talking about. We'll be talking about thermodynamics and kinetic study both. Here, this is how the diagram of the vessel. I'll show the vessel as well. We're having the gas cylinder, then gas booster is there, because it can develop a high pressure, because we need a high pressure. So that's why we do the boosting, and then we put into the video hydrate cell. Video hydrate cell means we can monitor That is why the down from the nucleation you can see the pressure line is getting down. So that is why it is confirming that the nucleation is there. Moreover, at that point I will be showing you the kinetic study. At nucleation, simultaneously decrease of pressure because the gas is going into the cages. At that same very point, because it was an exothermic phenomena, this rise of temperature should also be there. That only confirms that the hydrate formation has taken place. Simultaneously, down of pressure and rise of temperature peak is going to confirm that the hydrate formation has taken place. So over here, this is talking about after the formation, we'll be stabilizing it and then we are cooling heating it. After, you see, there is a point after which the dissociation started. After this you have just increased little bit of temperature, but you can see there is a substantial amount of rise of pressure. So that means dissociation has occurred. So means you are increasing temperature of same amount, but the amount of gas which has come out of the cages is more. So that means this dissociation has taken place. So this I have already explained. Over here, this study was with the hydrate formation without the presence of rhamnolipid. Now, how can I claim that my compound is promoter? How can I claim that it has acted as a promoter in the natural gas hydrate conditions, that these bacteria have provided a promoter role because they generated rhamnolipid? Why? Because in the vessel only we are showing that once we have made the rhamnolipid from those bacteria, then we are studying at 100 ppm, 1000 ppm and many ppm. Here I am going to show the result of 1000 ppm. Why that 1000 ppm dose is a promoter? You just see using this diagram. This is the diagram without the promoter, only silica gel. Here we are talking about with silica, with promoter, with 1000 ppm rpm. You will see now it will be promoter compound provided if you keep the same temperature. Then if it is a promoter, then it has to form the hydrate at lower pressure. Vis-a-vis, if otherwise it can because the hydrate formation is happening at high temperature and low pressure. One thing is that if you talk of same pressure, then it should rise the temperature, then it is promoter, no? Supposingly, if it is forming at 1 degree Celsius, then 1000 rhamnolipid, 1000 dose of rhamnolipid will form at 1.5 degrees Celsius if the pressure is same. If you are taking temperature as same, then it should lower the pressure. Supposing it is getting formed at 5 megapascal, then my compound should form at 4.5 megapascal. Then it is a promoter. Means one thing is that it is increasing the temperature of formation at a fixed pressure, or at a fixed temperature it decreases the pressure of the formation. Then it is promoter. So this is what this compound has done actually. Here you can see with the help of 1000 ppm and 100 ppm, you can see the if you talk of the same temperature, let's say 287 Kelvin, let's say for example. So that red one, when there is only water, is forming the hydrate at around between 10 to 10.2, but that green one is forming at around 9.8. So that means at same temperature, the hydrate formation has taken at lower pressure. So that's why I'm claiming that my compound, that is rhamnolipid, is a promoter, because it is at the same temperature the hydrate formation pressure has been decreased. So that is why it is a promoter. Now the kinetic study, that was the thermodynamic study. A thermodynamic study is a very long study. I mean, you'll have to do experiment day and night actually, sometimes for around 36 hours, sometimes for 48 hours. So it's a long study. From that study, let me go to that study back. Just a minute. I mean, I would like to show you this HSZ. HSZ means this hydrate stability zone. Hydrate is stable only in this HSZ. If you will move out of this zone, let's say for 285 Kelvin, you cannot you cannot make the hydrate. Getting over. You can make only hydrate in this zone only. Neither you can make beside this zone, neither you can make hydrate neither towards the left nor towards the right. Only in this zone only the hydrate is stable. This is the thermodynamic study. Means you can play with temperature and pressure using this diagram. If you want to make at a particular temperature, this diagram can tell you that at what particular pressure the hydrate will be formed. So this is the role of this diagram. So using this diagram, we note the temperature and pressure formation conditions of hydrate. Then those kind of conditions we'll be using into the kinetic experiments. In kinetic, I am worrying about how many moles of hydrate has been formed, how much gas is consumed, that is kinetic study. What order it has followed, that is kinetic study. But at what temperature and pressure, it's okay, we have softwares. But then okay, we compare with that, we simulate, we do a lot of things. But then we experimentally also do those kind of thermodynamic studies. From these studies, we note down the temperature and pressure. Those kind of temperature and pressure we use into the kinetic studies. So kinetic studies will be talking about the number of moles, the induction time. The induction time is the time, that is the nucleation time. कि कितने time के बाद जो है induction हुआ है. So that is what it is, the nucleation time. So that this diagram will be using actually for kinetic study. Here you can see here we are talking about the kinetic study. Here you can see the induction time is for the with 100 lamnolipid. This induction time with the 1000 lamnolipid. You can see the two curves. The red one is the temperature one. You just see what I was talking about. Simultaneously, there is a decrease of pressure. The black line is going down. At the same point, when the black line is going down, because the pointer is not working actually, so that's the reason. Otherwise, you can see simultaneously red line is going up. So that means simultaneously the pressure is rising and the temperature is rising and the pressure is getting decreased. So that confirms the hydrate formation. Now, a claim is like this, that why this is a promoter is, if I don't use any fixed bed media, I am going to form these methane hydrate in the same vessel at it will take around 196 minutes. If I don't use, if I use my compound, for example, let's say 1000 ppm, I'm going to form it in 34 minutes. So that means it is a kinetic promoter actually. So you can always use these kind of compounds for the natural gas hydrate pipelines and all that. Currently we are using very, very costly compounds. We are using antifreeze proteins and all that, which we are making for Bitel of those, permafrost regions. So Walker Group is there, they're working on this area. Vis-a-vis, we have got a patent where we have generated very, very low costing kind of, inhibitors. So that's why, because, you see, now here we will be talking about, we are saying that currently these kind of compounds, have a lot of substantial market, because currently the world is only using surfactants, which are, toxic. The toxicity is the issue. We are using sodium chloride sulfate, etc. So they are very much toxic, and these sort of compounds can definitely address environmental problem and a lot of other problems. So how this damnolipid is acting promoter? This is the mechanism. So because of the formation of my missile, so that missile actually plays a role, in collecting the hydrocarbons. So on the missile, the gas will collect, and this is how this will act as a promoter actually. Here, we are saying that many times the rate of formation will increase. The spherical missile, which is formed by the long chain carbon alkyl groups, the solubilized hydrocarbon gas. So the maximum amount of hydrocarbon gas is solubilized. The maximum amount of hydrate formation will take place. So actually this is the mechanism actually. We publish it in a nature group. So you see, we propose the mechanism, Here we are talking about that the water associates around the circumference of the missile, which is in close proximity of the solubilized gas. So this is facilitating to act as missile as a nucleation point. Nucleation point is the point where you will have a maximum amount of gas. So that is why that missile is acting as a nucleation point actually. So every compound have its own CMC, critical missile concentration. So this is the minimum kind of concentration which is needed to form the missile. So in case of rhamnolipid, the CMC is very less if you compare it with the STS. This is another advantage actually. The CMC of these kind of biosurfactant is less. So, but there are many, many challenges in front of gas hydrates. One thing is this, that the release. So we want to decrease the global warming, we want to put CO2 into the sea, but we may increase the global warming. Why? Because so this may happen once they start coming out of those beds, they can come at an uncontrolled rate. Imagine if you see the command quantum they have. I have shown in trillions of cubic meter in the beginning of my first introductory slides. If you are not able to control that kind of methane which is coming from the reservoir, so then it will be condition which is 360-degree opposite. You know, we want to control global warming, but so much amount of methane will be released that the it won't be a place to live. Earth won't be a suitable place to live. So this is the first signature which we need. Their controlled release is a problem actually, which is under study. Because greenhouse gases has played a vital role when the life was getting started. It got started because of greenhouse effect only. But here the conditions are different now. We can generate a temperature where blood will evaporate from the, because it has a boiling point. No? My skin is having blood down, but it has a boiling point. So that temperature can even come that the blood is gone out of the skin. So this is the amount of temperature they can increase if we are not able to control their sustained release. This is the challenge in front of the world actually, to all young people who are sitting in front of me. Then is the, you see, then there could be some kind of geological disasters. So because here, this is a novel resource of energy. Over here, if you talk of conventional, no phase transformation is occurring. You take oil out of the seabed, no phase transformation is occurring. You take gas out of the seabed, no phase transformation is occurring. But if you take hydrogen out of the bed, the phase transformation is occurring because this is SNG. It is solid natural gas. Because of this phase transformation, there could be geological disaster, there could be tsunami, there could be any kind of another disaster. So geologists are studying from this point of angle, whether once we able to start commercializing and taking this from the reservoir, whether those sort of tsunamis or those sort of conditions can prevail. So this is under study by the geologists actually. And one is the sustained release, which I have discussed. But then there are many other challenges. Another is the ecological disaster. You see, lot of flora, fauna, lot of zooplankton, phytoplankton, they are dependent upon that methane hydrate. They are using it as an energy resource. If you take that methane out, you will be just dissociating the methane hydrate. There won't be any methane hydrate. But see, many type of life is dependent on those kind of methane hydrates. So a lot of high amount of projects are under consideration where ecologists are studying that what kind of flora and fauna is existing. So that is again under study actually. And now these are the conclusions. So if we are able to give what this sort of energy resource, so no resource of energy can match with this. But this study has generated a rhamnolipids as a biosurfactant, and this biosurfactant is a biomass driven gas hydrate promoter. So biomass is a can be used. Lot of biomasses can be used for the formation of rhamnolipid. Then we have seen that the energy industry is looking not hydrate from energy point of view. They're looking from many applications like CO2 capture, like hydrogen storage, like CO2 sequestration, like desalination. So in that case, tomorrow, if this becomes a reality, that kind of promoter will be in very much demand, because lot of RO will be going out of the kitchen, and hydrate based desalination will be the future actually. So in that case, that methane hydrate formation using those kind of biosurfactant will be very much vital. And then, for example, if tomorrow natural gas hydrate from the ocean floor becomes a viable natural resource in future, then this study that how they are getting formed, how we can dissociate them will be of vital importance actually. So that's it. And there are many other conclusions, like if you are able to exploit only small percentage of them, then even then you need not to worry about the energy factor, energy for many centuries actually. So the you see, we can always give this as a energy resource for our future generations, And CO2 sequestration, if we are exploiting them through CO2 sequestration, then we can solve both the problem, the energy and the environment, both in a one go. And there are many countries like US, China, Japan, they are shaking hands with India, and there are long term of testing which is planned in USA. We are testing in Japan also, and if you see, it is expected that the dream of taking energy from this fiery ice will be reality very soon. However, there is a strong need to prepare a suitable green technology for exploiting this untapped resource of energy. India has completed NGHPN, that is the National Gas Hybrid Program 1. India has completed NGHP 2, and Government of India is planning to go for NGHP 3 as well. In NGHP 2, we have marked the locations and we have tested we have already formed the hydrate and exploited the hydrate in the vessel only, which we are going to test in the real gas hydrate conditions on the sea. So those has been tested in the vessel as well. And the NGHP, we have marked the methane resource rich conditions. So those have been tested in vessel as well. And in my opinion, if some cluster is made by combining energy, environment, and earth sciences, then at least it can be help in designing a novel, viable, cleaner, greener economic technology to exploit this huge white gold and which can redefine the economy of India, of a nation like India. So means we currently don't have any technology, but if we are able to design it, then India will be definitely is a is a superpower in the timings to come, because we have maximum amount of hydrate and we are having at a very shallow depth or our exploitable one. Whole world is looking at India to go for the first commercialization of these hydrates actually. So this is, I'm saying that it is not only it's a real that this published news I have brought from it is latestly published I think in the month of February only, February 3 to 2025, that the gas hydrate market size share in industry, they are saying that it is rising. Here, this is again a news that the gas hydrate market size is going to be 3.78 billion by 2033 CJR. Again, it's from New York, United States, August 7, 2024, that its share is rising. Storing carbon in the form of gas hydrate under the sea. Here, this is the this is the Bay of Bengal. That the gas hydrates can be game change player in the Bay of Bengal. Here we are talking about that the if we are able to by 2030 probably we'll be able to tap them. So we have published these studies in many journals. This study is published for CO2 capture through hydrates. This is published in the American Society of Mechanical Engineers. This is in Material and Design. It's again a CO2 hydrate capture. This is with scientific reports. This is with the recently we have investigated now. We don't have the synchrotron over here. We collaborated with the National Oceanography Institute of Southampton, where we have a synchrotron. We have observed that how the while the nucleation is taking place, using that synchrotron, we are seeing that what is the changing which is happening. So we have used that synchrotron. One of my PhD student, he has used it at University of Southampton, and we have seen how the dynamics of bubble is getting changed actually. So we have recently published this study actually using synchrotron, which is 40 time lapse. It's a very new 40 time lapse synchrotron. This is how the bubble dynamics is getting changed actually. This is the last paper. My candidate from IIT Roorkee, she is just submitting thesis. I think within a day, next week she's submitting. So recently we published the isotropic and anti-isotropic permeability on gas hydrate formation of this site. We are working on modeling and simulation of many sites as well. However, I'm taking about maximum part of experimental part, but then we have a team. So many of my students are working together for mathematical studies as well. This is the latest study which we have published, I think last month. So these are the patents which we are having on the field of hydrates. So these are some other areas like flow assurance. I work on biomass valorization, biolubricants, human implants, and targeted delivery, lung carcinoma, and there are many other areas actually, flow through porous media. So we are, open for the collaboration. So anybody can visit NIT Hamirpur in my lab, and we are also looking, students, So that's why I've shown my other areas as well. So all of you are welcome. So this is sorry. Again, thank you for patiently listening. These are the references. Again, I really thank Professor Shastri for giving me this platform, and I'll be feeling my duty if I really don't thank Dr. Sharman for providing fantastic hospitality, and Professor Shastri and Professor Sharman. I'm really thankful for providing such a good hospitality. And do visit us sometime, all of you. Thank you. If any questions are there, so I think I kept in time. I tried to keep it. Many things I have shuffled only because I was asked to keep it in time, but still I think there is a delay of 4 or 5 minutes. So I'm sorry for that. So if any questions are there, I'd love to take those questions if any questions are there. Fine, then let's stay connected down the lane. Thank you. Thank you.
Thank you so much, sir, for enlightening us with such a wonderful and knowledgeable session on thermodynamics and kinetic study of methane hydrated as a novel energy resource. So now, I would like to request Dr. Shravan Kumar, sir, to please come up on the stage and felicitate Dr. Amit Arora, sir, for his great work. Please come on the stage. Thank you, sir. So now it's a time to introduce our next esteemed speaker, Dr. Sonti Ramesh. And to the honors and present the speaker's mysterious journey, I would like to invite Mrs. Mishika Verma of First BTech Chemical Engineering to the stage to enlighten us with inspiring biodata of our esteemed speaker.
Good evening, everyone. It is an absolute honor and privilege to introduce our esteemed speaker today, Dr. Ramesh V. Sonti sir, Director of the International Center for Genetic Engineering and Biotechnology, New Delhi. Dr. Sonti sir is a distinguished scientist whose contributions to plant microbe interactions and crop improvement have had a lasting impact on the field of biological sciences. His academic journey began with a BSc from Andhra University, followed by an MSc and MPhil from the University of Hyderabad. He went on to earn his PhD in bacterial genetics from the University of Utah, USA, and further honed his expertise through postdoctoral research at the Massachusetts Institute of Technology, Cambridge. His illustrious career includes leading roles at premier institutions like CSIR Center for Cellular and Molecular Biology, CCMB, the National Institute of Plant Genome Research, and IICHE Tirupati, where he served as chairperson of the Biology Department and Dean of Faculty. His contributions to science have been widely recognized with prestigious awards such as the Shanti Swarup Bhatnagar Prize, the National Bioscience Award, and the J.C. Bose Fellowship. A fellow of multiple National Science Academies, Dr. Sonti Sir has been instrumental in the development of improved Samba Mahasuri, a bacterial disease-resistant rice variety that has significantly benefited Indian agriculture. His leadership in research and innovation has earned him accolades such as the CSIR Award for SNT Innovations for Rural Development and Biotech Product and Process Development Award. Today, we are fortunate to hear from a scientist whose groundbreaking work bridges fundamental research and real-world applications. Please join me in welcoming Dr. Ramesh V. Sonti, sir.
Thank you, everyone, and good afternoon to all of you. Thanks to Professor Shastri for inviting me here. I must confess that when he asked me to give a talk in this conference of chemical engineers and biochemical engineers, I thought that I would be out of place. But what Dr. Shastri told me is that cross-disciplinary interactions are important, and bringing in a different perspective in this particular conference can actually help kickstart many collaborations and cross-fertilizations of ideas. So it is with this in mind that I come before you to give you a brief overview of the kind of work that my institute does. I work at the International Center for Genetic Engineering and Biotechnology. Our focus is on using the modern tools of biotechnology to solve problems for the developing world, whether these are in medical, in human, things related to do with human health, or industrial microbiology or crop biotechnology. And I will try to cover the work that is done in our institute with a major focus on the fundamental problem of our times, which is the issue of climate change and how it is going to affect all of us and how we can actually try and either reverse it, or if you are not able to or in the process of reversing, how do we adapt to it. So make it the next slide, please. So I begin with this report from the Intergovernmental Panel on Climate Change. The Intergovernmental Panel on Climate Change gave their synthesis report in 2023. Every few years they give this report that serves as a guidance document for governments worldwide and also for intergovernmental agencies on issues related to climate change. And what their latest report says is that climate change is not a hypothetical matter, it is a clear and present danger. And what they actually say is that there is a rapidly closing window of opportunity to reduce greenhouse gas emissions, which are the fundamental factors behind climate change, and to be able to control global warming. So that's the message that comes from this report that came out in 2023 from a very influential intergovernmental body. Now, going back 10 years ago, the Paris Agreement that many governments all over the world have signed on to, including our country, have actually committed themselves to control and reverse global warming. And the decision that has been made at that time was that it would be preferable to cap global warming at about 1.5 degrees centigrade above the pre-industrial levels. Now, what this latest report tells us is that between 2011 to 2020, global surface temperatures have already reached, 1.5 degrees centigrade above pre-industrial rates. So while the Paris Agreement says that we should cap it at 1.5, we already reached 1.4, 1.1. And anything over 2 degrees centigrade will be catastrophic for all life on Earth. That's the scenario that we are faced with. Now, what are these greenhouse gases? I think Professor Arora was mentioning about different greenhouse gases and the need to combat them. It's primarily CO2, but methane and nitrous oxide are also important. And where do these greenhouse gas emissions come from? About 78% of these greenhouse gas emissions come from the industrial sector, the energy, transport, construction, etc. And about 22% come from agriculture and forestry. Now we all see the effects of adverse weather events caused by climate change. Every year we hear about a disaster somewhere or the other in our country. And it's also known, this is again very clear, between 2006 to 2018, there has been a 3.7 centimeter rise in sea levels worldwide. Imagine all the oceans in the world, how much water is required to raise the sea level by 3.7 centimeters all over. And where is it coming from? This water is coming from polar ice caps, glaciers, etc. that are melting due to climate change. And you can actually see, I mean, this is just sort of a typical example of, it's a picture that captures what sort of effects they're going to be in the world because of climate change. What we are actually seeing is adverse weather events, sea levels rising, inland areas, a lot of coastal areas are now becoming saline because the sea water, because of rises in sea levels, that water is actually ingressing inland. Glaciers are retreating, polar ice sheets are there. One part of it is that we are facing a climate change crisis. Coupled with that, we are also in the midst of a biodiversity crisis. And this is a report that came out in 2022 by the World Wildlife Fund. They published what is called the Living Planet report. And if you actually see, they've calculated the number of individuals of each species that were there on our planet between 1970 to 2020. Now, this is not talking about species that have gone extinct. These are species that are currently there, but the number of individuals in populations of these species are drastically reduced. So that is a real biodiversity crisis because our cohabitants on our planet are actually disappearing from the planet. So we have a climate change crisis and we have a biodiversity crisis. In the middle of it, we need to develop as a country. And the goal that has been set up by the government of India is for our country to be a developed nation by 2047. Even under normal circumstances, this is a very, very challenging task. But to get economic growth, including substantial job creation, under conditions created by this climate change crisis and the biodiversity crisis, is a real, real challenge. So how do we actually cope with it? Now I will come to you from the perspective of a biotechnologist, looking at the whole field of our economy and how climate change is going to be affecting various sectors of the economy, including agriculture, animal husbandry, fisheries, industry, health, environment. Every aspect of the world around us is going to be affected because of climate change. And I will tell you a little bit about how biotechnology can be used. And this is where it's not just biotechnology, as you will see, and as I go along, there is going to be a lot of collaboration between biotechnologists, industrial engineers, chemical engineers, biochemical engineers. A lot of us will have to come together, electronics, computational, computer scientists. A lot of us will have to be able to come together if our country is to come up with a new paradigm of development that is inclusive, friendly to the environment, and does not add to the crisis of climate change. What I will do, I myself, as during the introduction it was mentioned, I myself I'm a crop biotechnologist and I work in the area of agriculture. So I'll spend a little bit of time in how biotechnologists and computer scientists, etc., are going to be able to have to work together to help agriculture deal with the issues of climate change. What is already clear is that warmer temperatures, these are laboratory scale experiments, the warmer temperatures that are coming ahead are going to be reducing yields of major crops such as rice, maize, wheat, and soybean. Our soils are becoming saline. And what is important is, in previous years, you would actually say this part of the country will have drought, this part of the country may have flood, and when a drought happens, it happens in an occasional year. When a flood happens, it happens in an occasion. But what is now happening is that in a single season, in different parts of our country, in the same place, you can actually get a flood and a drought. Last year, there were instances in our country where in the month of August there was flooding, and in September there was drought. So we need to now develop crops that are resilient to these kinds of multiple stresses, and the whole agricultural environment has to change to be able to cope with it. So I will just give you one example of how biotechnologies are working to solve these problems, and I'll just give you an example from our own work, again that was briefly mentioned during the introduction. There is a disease called bacterial blight. I mean, it's a very, very serious rice disease. And this is a picture taken in Andhra Pradesh of a rice field affected by this particular bacterial disease. So we developed, again, I will not go into all these details. It is now possible to very rapidly, in a period of 3 years, we actually took a very, very premium rice variety and made it resistant to this bacterial disease. What you see in the background is a variety called Samba Masuri, which is susceptible to the disease. I mean, it has, this is what happens to that variety when the disease happens. And we developed a variety, and that's what is seen in the foreground, where we developed a rice variety that is resistant to the disease. Now, this is being grown in now about 7 different states in our country, and last year it was grown in about 1 million hectares of rice crop within the country. So not only disease, we are now actually moving forward to make this particular variety resistant to bacterial disease, resistant to conditions of low phosphate, that means nutrient use efficiency, salinity tolerance, disease resistance, drought tolerance, etc., etc. What is actually clear is that with biotechnology, you can actually develop these varieties that are tolerant to multiple stresses that we are going to face due to climate change. There is one more point I want to tell you. These are again these new tools that are becoming available. What you see on the left is a plant called teosinte. Now, teosinte is a wild relative of domesticated maize, which is the plant that I'm showing you here. This wild teosinte is very resistant to stresses. So everything that climate change can throw at that plant, teosinte will be resistant. But it doesn't yield well. During the process of domestication, our ancestors, that is, people who lived maybe 10,000 years ago, they domesticated teosinte and picked varieties of teosinte that now had better yield. That's what we see in the right hand side of maize. But the problem is that while we picked it, now what we are doing is we are taking care of those crops. Those crops are now no longer able to take care of themselves. We are taking care of those crops. So this maize now that is high yielding is not, it is very, very susceptible to various diseases. So what people are trying to do, and this I'll give you an example of work done a few years ago by another group in what they've actually done is that they've used a new technique called genome editing. What genome editing does is that you can go directly into that. Now it makes these bigger fruits. And you can actually see an example here.